All right, so maybe you're like me. You're ready to finally tackle this OpenAI documentation.
Yeah.
But, as a Python beginner, just 3 months in, it's a little intimidating, right? I mean, where do you even start? That's why we're doing this deep dive.
Yeah,
We're going to help you build a mental map before you even open up those docs.
that's exactly right. The goal here isn't to cover every single detail, but just to give you a framework so you can approach that documentation with confidence,
Right.
not with confusion.
And what you'll find out is that OpenAI is way more than just sending lines of code. It's actually designed for this back and forth, like an exchange
Yeah.
of information.
It's almost like a conversation.
Oh, interesting.
With a super smart assistant, you can send information, you can get responses, you can build upon previous interactions.
Okay, so if I'm picturing myself sending info to OpenAI, I'm thinking, lines of Python code.
Sure.
But is there anything else? Can I send, like, other stuff?
Well, beyond your code, you can send up to 10 files per request.
What files? Like, what are we talking here?
We're talking things like Dalal, images, files you've uploaded yourself, even files created by a feature called Code Interpreter, which is basically letting OpenAI write and run its own code in a secure environment.
Hold on, Code Interpreter. That's a whole other thing.
It is. We'll get there. But the key takeaway here is that these files, they become part of your conversation with OpenAI.
Oh, okay.
Imagine you send a PDF instruction manual alongside your code. So OpenAI understands the context of what you're trying to do. That's the power of files.
So that's not just my code. It's got extra info.
Exactly.
Okay, that's pretty cool. But how do I actually send these files? Do I, like, paste the whole thing into my code? That seems messy.
Yeah, you're right. That wouldn't be very efficient. That's where this thing called OpenAI file address comes into play.
Okay.
Think of it as a pointer system.
Right.
You don't send the entire file. You send a reference ID
Okay.
that points to the file already stored within OpenAI.
So it's like I'm giving it the address, not the whole package.
Exactly.
I got it.
Yeah.
But I'm guessing there's, like, a specific way to format these IDs, right?
You bet. The documentation specifies a format using an array of JSON objects.
JSON objects.
Now, before you freak out,
Go for that.
let's just break it down simply. What is a JSON object? It's just a way to organize information using key value pairs,
Okay.
like a digital filing cabinet.
So it's not as scary as it sounds.
Not at all.
But can you give me, like, a real-world example of what a JSON object looks like, with these files?
Absolutely. Imagine you have a file called myreport.pdf. A simple JSON object representing that file could look like this. You have name : myreport.pdf, comma, itime, : filedaxyz123.
So name is the key, myreport.pdf is the value, and then same with ID and that unique file identifier.
Exactly.
Okay, see.
And the documentation provides a clear example of how these OpenAI file address should look in a real request.
Okay.
It might look a little cryptic at first glance, but once you see it in action,
Yeah.
it'll click.
Okay, well, let's see it in action.
Sure.
Can you walk me through an example from the docs?
Yeah, if you look at the sending and returning files PDF, you'll see an example and notice these fields: name, EID, MIME type, and download link. These are all crucial pieces of information that help OpenAI identify and utilize those files you send.
Okay, so I see those fields, but the schema in the documentation says array of type string, and this example is JSON objects. That seems a little bit confusing for a beginner.
You're absolutely right. That's one of those quirks in the documentation that can trip people up, even though it might say string in practice. You're working with those JSON objects.
Okay, so it's a little different.
Just a little.
Got it. So just to recap, I'm sending these files. OpenAI is remembering them,
Right.
and it's using them to understand the context of my requests.
Exactly.
This is pretty powerful stuff.
It is.
But what happens when OpenAI creates something based on my code and my files? Can I get that back?
Absolutely. OpenAI can return files to you, although there's a size limit, 10 megabytes, and it can't return images or videos. To handle this, there's a special parameter called OpenAI file response.
Okay, another term for the glossary.
Right.
So OpenAI file response handles the files coming back from OpenAI.
Exactly.
Does it work the same way as OpenAI file refs?
It's similar in that it uses JSON objects, but there are some key differences. First, OpenAI file response is always an array, even if it's just returning a single file. And second, there are two ways to get those files back in line and URL.
Hold on. Two options, inline versus URL. Break those down for me.
Sure. So think of inline as getting the file directly embedded within the response. It's like OpenAI saying, here's the data right here, right now.
Okay.
The URL option, on the other hand, is like OpenAI giving you a link to download the file.
So inline is instant URL is like a download link.
Exactly.
Gotcha. But how do I choose which one to use? Is there like a rule of thumb?
A good rule of thumb is think about file size. If it's a small file, inline is convenient because you get that data right away.
Okay.
But for larger files, URL is a better choice because it prevents your code from getting bogged down with all that data.
That makes sense. So small files, inline, big files, URL.
Yeah.
But I'm guessing the best choice also depends on what I'm actually doing with the file, right?
Exactly. As you get more experience with OpenAI, you'll get a better feel for which method is best for different situations.
Right.
But just knowing those two options exist
Yeah.
is a great starting point.
Okay, so far, we've covered sending files to OpenAI, which is like giving it the building blocks for our conversation.
Right.
And we've learned how to get files back from OpenAI, which is like receiving its response.
Precisely. And this ability to send and receive files is a crucial part of that dynamic interaction you have with OpenAI.
Okay, my head is swimming with all this new information.
It's a lot to take in.
But in a good way. Can we see how all of this comes together in like a real-world example?
Absolutely. Let's say you're working on a project where you need to analyze a bunch of legal contracts
Okay.
and summarize the key points.
I'm intrigued. Tell me more.
You could upload each contract as a separate PDF file to OpenAI and then use your Python code to send a request to OpenAI asking it to analyze those contracts.
So I'd use those OpenAI file iDrefs
Exactly.
to point to the contract.
Exactly. And you would include instructions in your code on what type of summary you're looking for, maybe specific clauses or sections you're interested in.
And OpenAI would send back a summary of the contracts, possibly as like a text file that I could then download using OpenAI file response.
You got it. This is just one example, but it illustrates how powerful this file handling capability can be.
That's pretty amazing. I never would have thought I could do something like that. Just starting out, this is really opening my eyes to the possibilities of working with OpenAI.
That's what we're here for. And remember, this is just scratching the surface. As you dive deeper into the documentation, you'll discover even more ways to leverage files and expand your OpenAI toolkit.
I can't wait. But before we move on to the next topic, can you just remind me one more time what that OpenAI file iDrefs thing is all about? I just want to make sure I have that concept nailed down.
Remember, OpenAI file iDrefs is all about referencing files that are already stored in OpenAI. You don't send the actual file data, just a reference ID.
Fine.
Think of it like giving OpenAI the address of the file instead of the whole package. And those reference IDs are formatted as an array of JSON objects, which are simply a way to organize information using key-value pairs.
Okay, that's much clearer now. Thanks for the recap.
No problem. And remember, the documentation provides lots of examples and details, so don't be afraid to refer back to it as needed.
You're right. I'm starting to feel a lot more confident about tackling the OpenAI documentation. It's not as scary as I initially thought.
That's the spirit, and the more you work with it, the more comfortable you'll become.
So we've talked about sending files to OpenAI, but what about getting information back? You mentioned OpenAI file response, and I'm curious to learn more about how that works.
That's a great segue into our next topic. OpenAI file response is all about how OpenAI sends files back to you, and it has a few tricks up its sleeve. So as I was saying, OpenAI file response, this is how OpenAI sends files back to you, and as we've already touched on, it always comes as an array, even if it's only sending back a single file.
Right, and you mentioned there are two ways to receive those files, inline and URL. Can we maybe dig into that a little more? Like, when would I choose one over the other?
Okay, so let's say you're building a chatbot that needs to quickly display small text files like definitions or short summaries. In this case, inline would be perfect because you get the data right away embedded within the response. But if you're generating large data files, maybe from analyzing spreadsheets or crunching numbers, then URL is the way to go. It provides a link to download the file, preventing your code from getting bogged down.
So it sounds like a classic speed versus size trade-off. Smaller files inline for instant access and larger files as a URL to avoid slowing things down.
Exactly. And as you work more with OpenAI, those specific use cases will become clearer. But just knowing you have these two options to receive files, it gives you a lot of flexibility.
Speaking of flexibility, earlier we briefly touched on code interpreter. You said it's like OpenAI can write and run its own code. That sounds incredibly powerful. Can you elaborate on that a bit?
Yeah, imagine you're writing a research paper and you need to find relevant academic articles.
Okay.
You could upload a bunch of research papers as PDFs to OpenAI and then have Code Interpreter actually analyze them. It could extract key findings, identify common themes, even generate a summary of all the papers.
Wait, so OpenAI is not just processing my code, it's actually generating and running its own code to do things like analyze those research papers.
Precisely. It's like having a mini programmer inside OpenAI working for you. And the best part is those files created by Code Interpreter can also be sent back to you using OpenAI file response.
So it's a seamless workflow. I provide the input files and instructions. code interpreter does its magic behind the scenes, and then I receive the output files.
Cool.
That's pretty mind-blowing.
It is, and it opens up a whole new level of possibilities for what you can achieve with OpenAI.
Okay, my brain is definitely buzzing with ideas right now, but I also have to admit, this is a lot to take in.
Hmm.
For someone like me just starting out with OpenAI, where's the best place to start with the documentation?
Yeah, don't worry, you don't need to read it cover to cover. I'd recommend starting with the Quick Start Guide. It provides a basic overview of how to set up your API key and make your first API call.
Okay, quick start check. What's next?
Once you have the basics down, I'd suggest checking out the section on models. This is where you'll learn about the different types of AI models available and how to choose the right one for your specific task.
Right, because OpenAI isn't just one thing. It's like a whole family of models, each with their own strengths and weaknesses.
Exactly, and then you'll definitely want to spend some time with the sections on completions and embeddings. Completions is all about generating text and code, like writing stories or creating chatbot responses, and embeddings is about representing text and code as numerical data for machine learning tasks, things like sentiment analysis or clustering similar documents.
So quick start models, completions, embeddings.
Yeah.
Got it. What about all this file handling stuff we've been talking about? Is there a specific section for that?
You'll find information on file handling throughout the documentation, especially in sections related to specific API endpoints. But the concepts we've covered today, like OpenAI file iDrefs and OpenAI file response, will help you understand those sections.
Okay, that's reassuring to hear. I'm starting to feel a lot less intimidated by the documentation, but I'm curious, is there anything in the documentation that surprised you, even as a seasoned OpenAI user?
Honestly, I'm still amazed by the sheer breadth of applications for OpenAI. The documentation covers everything from generating different creative text formats like poems and scripts to answering your questions in an informative way, even if they're open-ended, challenging, or strange. It can even follow your instructions and complete your requests thoughtfully. It's just incredible to see all the creative ways people are using OpenAI.
It's like the possibilities are endless. Now that I'm starting to understand the basics, my mind is racing with ideas.
That's fantastic. And remember, the documentation is a living document. It's constantly being updated with new features and examples, so don't be a stranger. Keep coming back and exploring.
So the OpenAI documentation, it sounds like it's more of an ongoing journey than a destination.
That's a great way to put it. Embrace the learning process, and you'll be amazed by what you can achieve.
Speaking of the learning process, I have to admit I still feel a bit shaky on those JSON objects we talked about earlier. Can we go back to that for a moment?
Of course, remember, JSON objects are just a way to structure information. They consist of key-value pairs, where the key is like a label and the value is the actual information.
Right, like name and myfile.pdf. Can you give me another example, maybe something a little more complex?
Absolutely. Let's say you have a file with some metadata, like the date it was created, and the author, you could represent this as a JSON object like this. File name, mydocument.txt, date created, 2023-12/28. Author, Jane Doe.
So in this case, file name, date created, and author. Those are the keys, and the corresponding values are the actual file name, date, and author's name.
Exactly. It's a simple yet powerful way to organize and transmit information.
Okay, that makes a lot more sense now. Thanks for taking the time to explain it again. I really appreciate it.
No problem at all. Remember, there's no such thing as a dumb question, especially when you're learning something new.
So we've talked about how to send files to OpenAI using OpenAI file iDrefs, and we've seen how to receive files using OpenAI file response.
Yeah.
I'm feeling much more confident about those concepts now, but we haven't really talked much about that conversation aspect of OpenAI that you mentioned earlier. Can you elaborate on that a bit more?
Of course. That's actually a great point to transition into a deeper dive on how OpenAI interactions really work. It's not just about single requests and responses. There's a whole back and forth dynamic that you can leverage to build really sophisticated applications.
So you're saying it's not just like one and done right. It's not just sending a single request and getting a single response back. It's more like an ongoing dialogue.
Yeah, exactly. Now think of it like a conversation with a colleague. You might start by asking a question, they provide some information, and then you build upon that with follow-up questions or requests. OpenAI works in a similar way.
Okay, can you give me a concrete example of how that might play out?
Sure, imagine you're building a travel planning app. The user could start by sending a request to OpenAI asking for travel recommendations based on their preferences. OpenAI might respond with a list of potential destinations along with some basic information about each place.
Okay, so that's like the first exchange in the conversation.
Right.
What happens next?
Well, the user could then send a follow-up request asking for more details about a specific destination that caught their eye. Maybe they want to know about the best hotels in the area or what the weather is like during a particular month. OpenAI would then use the context of the previous conversation, remembering what the user has already asked and the information it has already provided to give a more relevant and helpful response.
So each request builds upon the previous one, and OpenAI is keeping track of that entire conversation history.
Exactly.
That's pretty cool. But how does file handling fit into this conversational model?
Let's say the user wants OpenAI to help them create a customized itinerary. They could upload a file containing their travel dates budget and any specific activities or sites they want to see. OpenAI could then use this information along with the previous conversation history to generate a detailed itinerary that meets their needs.
So the files become part of the conversation, just like the text-based requests and responses.
Right.
It all contributes to OpenAI's understanding of what the user wants to do.
Exactly.
This is really starting to click for me.
Awesome. I'm glad to hear that. And remember, the documentation has even more examples and details about this conversational approach to using OpenAI. It's definitely worth diving deeper into.
I'll definitely be checking that out.
Yeah.
This whole deep dive has been so incredibly helpful in breaking down the OpenAI documentation. I feel so much more confident about exploring it on my own now. But before we wrap up, is there anything else that you'd recommend for someone just starting out with OpenAI?
Yeah. One thing I always suggest is to experiment and have fun with it. Don't be afraid to try different models, different prompts, and different ways of using the API. The more you play around with it, the more you'll discover what's possible.
Yeah, and it sounds like the OpenAI community is a great resource too, right? There are forums and online groups where you can connect with other developers, ask questions, share ideas.
Absolutely. The OpenAI community is incredibly supportive and active. There are tons of resources available, from official documentation to blog posts, tutorials, and online communities where you can find help and inspiration.
That's great to know. So to recap, we've demystified some of those intimidating terms, like OpenAI file iterefs and OpenAI file response. We've explored the power of code interpreter, and we've seen how OpenAI interactions work more like a conversation than a series of isolated requests and responses. I'm feeling way less intimidated by the OpenAI documentation now, and honestly, I'm kind of excited to dive in and start building something.
That's fantastic. And remember, the journey of learning OpenAI is a marathon, not a sprint. Embrace the challenges, celebrate the successes, and never stop exploring.
I love that. And to our listeners, if you're ready to unlock the power of OpenAI, remember that you don't have to go it alone. The community is there to support you. The documentation is your guide, and now you have a mental map to navigate it all.
So go forth, experiment, create, and who knows, maybe you'll be the one teaching us something new in the future.
That's a great thought. And on that note, we'll wrap up this deep dive into the OpenAI documentation. Until next time, keep learning, keep coding, and keep pushing the boundaries of what's possible with AI. All right, so we are going to dive into the OpenAI documentation today. And, you're a few months into learning Python, and this documentation can look kind of like a wall of text.
It's a lot, yeah. But it really is like this amazing toolbox with all these incredible possibilities to build with AI.
Okay.
And our goal today is to kind of equip you with like a mental map so you can know exactly which tool to grab when you need to use it.
I love that.
Yeah.
That's a great analogy.
Yeah.
So we're not going to reinvent the wheel or anything. We're going to teach you Python from scratch.
Right.
But we're going to give you those core concepts and demystify some of the jargon and help you understand how the whole OpenAI system kind of fits together.
Exactly. And you've already got some Python under your belt, so we can kind of skip the super basic stuff and just jump right into the good stuff.
Okay, awesome. Let's do it.
All right.
One of the first things that jumps out at me from the documentation is this idea of prompt engineering.
Yes.
What is that?
So prompt engineering is really all about learning to speak the language of these really powerful AI models.
Okay.
And you can imagine, like, if you're giving someone directions and you're super vague, they might end up totally lost, right?
Right.
Same with AI.
Okay.
The clearer and more specific your instructions are, the better the results that you're going to get.
So it's not just what you ask, but how you ask it.
Exactly. Yeah. The documentation is a great example of this with Excel formulas.
Okay.
If you ask something general, like, how do I add numbers in Excel? You're going to get a pretty basic answer.
Right.
But if you say something really specific, like, how do I add a row of dollar amounts and do that automatically for a whole sheet and have the totals appear in a column called total, then the model can give you that really precise formula you need.
Oh, that makes a lot of sense. So like the more information you give the model up front, the less it has to guess about what you actually want.
Right, and that actually leads into another fascinating concept, which is the idea that the model needs thinking time.
Okay, tell me more about that.
Yeah, so it's easy to think of these models as like instant magic, but they're actually processing a ton of information behind the scenes.
Right.
It's kind of like if you were asking someone to like solve a complex math problem in their head, you wouldn't expect an immediate answer, right?
Yeah, no, definitely not.
So sometimes the model needs a moment to think things through before it can give you the best response.
So it's not just about feeding it information, it's about giving it time to process.
You got it. And the documentation actually highlights how giving the model that thinking time can lead to greater accuracy.
Really?
There's this really cool example where a model is asked to check a student's solution to a solar panel installation problem.
Okay.
And initially, it misses an error.
Oh.
But when it's instructed to first solve the problem itself before evaluating the student's answer, it actually catches the mistake.
Wow, that's fascinating. So you're saying like, hey, model, walk around the problem, get like a sense of it, and then tell me what you think.
Exactly.
That's really cool.
Yeah, it speaks to the importance of really understanding how these models work.
Yeah, definitely. No, the documentation talks a lot about the power of providing examples, especially with something called few-shot prompting.
Yes.
What is that all about?
So few-shot prompting is this technique where you give the model a few examples of the kind of output you're looking for.
Okay.
So you're kind of providing like a style guide, you know?
Right.
There's this beautiful example in the documentation about teaching concepts like patience and the ocean.
Okay.
And the initial prompt uses this really poetic language, you know, about rivers carving valleys and symphonies, starting with a single note. And then when you ask it to teach me about the ocean, it carries that poetic style forward.
Oh, wow. So if you want your AI to be a poet, feed it some poetry.
Exactly. It's all about setting the stage and giving it that context.
That's amazing.
Yeah.
This next one kind of feels very familiar from my Python learning so far.
Okay.
The documentation really emphasizes breaking down complex tasks into smaller, more manageable pieces,
Right.
just like we do when we write code, right?
Exactly. It's like you nailed it there.
Okay, good.
It makes it so much easier for the model to digest.
Okay.
You know, imagine if you were building a customer service chatbot.
Okay.
You wouldn't just throw every possible question at it at once, right?
Right.
You'd kind of categorize them first.
Yeah, you'd have like billing and technical support.
Exactly. And that's where something called intent classification comes in.
Okay.
By figuring out what the user's intent is, first you can then direct them to the right part of the model's instructions.
So it's more structured.
Way more structured and efficient.
Okay, so instead of one giant messy model,
Yeah.
you're creating smaller, more specialized modules.
Exactly. And it helps to kind of think about it like building a website. You wouldn't cram all the content onto a single page, right? You'd organize it into different sections.
For a better user experience.
For a better user experience, exactly the same principle applies here.
Okay, and speaking of expanding capabilities, this is where things get really exciting.
Right.
Because the OpenAI API isn't limited to just working with language. It can connect to external tools,
It can.
which opens up a whole world of possibilities.
A whole world.
So tell me more about that.
Yeah, it's like going from a basic calculator to like a full-blown computer.
Wow.
The API can access and process information from all over the place.
Okay.
It's like having this super-powered assistant.
Okay.
One way that it does this is through something called embeddings. And now these aren't the kind that you'd find like on a piece of jewelry or anything.
I'm going to ask about that.
Yeah, in this context, embeddings are these numerical representations of text, and they kind of capture the meaning and the relationships between words.
Okay.
And the API can use them to search a massive database for relevant information.
So kind of like a supercharged search engine.
That's a great way to put it.
And that's really cool.
Yeah, and it goes beyond just finding information. The documentation also talks about how the API can use code execution to actually solve mathematical equations.
Wait, so it can like do the math for you?
It's like having this built-in calculator that can handle all the really complex stuff.
That's incredible. So much power in one place.
It really is remarkable.
It is.
But with all this power comes the need for really careful testing.
Yeah, I can imagine.
And that's why the documentation really emphasizes testing any changes that you make to your prompts systematically.
Yeah, I was just thinking that even like a tiny change in the wording could have a huge impact on what the model spits out.
Absolutely. And that's why it's so important to really see how those modifications affect the response.
Okay.
And there's actually this really cool concept they mentioned called model-based evils.
What are model-based defaults?
So essentially, you're using models to judge the quality of other models' outputs.
Well, wow.
Yeah.
AI evaluating AI.
It is. It's pretty meta.
That's very meta.
It is, and it highlights the growing sophistication of these tools.
Yeah, we've covered a lot here. We've talked about prompt engineering thinking time for the model, using examples, breaking down tasks, external tools, systematic testing. It feels like we've only just scratched the surface.
It's a really good start, though.
Yeah.
These are those foundational concepts that will really help you navigate the rest of the documentation with confidence.
I'm ready for more. What's next?
Well, there's one crucial aspect of the OpenAI ecosystem that we need to dive into, which is the concept of tokens.
Okay, I'm all ears. Let's talk tokens.
So tokens are essentially like the building blocks of how these OpenAI models understand and process language.
Yep.
Kind of like, imagine you're building a house with Lego bricks.
Right.
Each brick is like a fundamental unit, a unit of construction. And tokens are like those Lego bricks, but for language.
Okay.
They represent individual words or parts of words or even punctuation marks.
So when I send a prompt to an OpenAI model, it's breaking down that prompt into these individual tokens.
That's exactly right. And each token is actually represented numerically, which is how the model can actually work with the text.
Okay.
It's kind of like translating language into this code that the model can understand.
That makes sense. But why is it so important for me as like a user of the API to understand tokens?
Yeah, so for a couple of key reasons. First, understanding tokens helps you really grasp this concept of model context.
Okay.
So each model has a limited number of tokens that it can handle at once, kind of like a memory capacity.
So there's a limit to how much information I can feed it in a single prompt.
You got it. And if your prompt is too long and exceeds that token limit, you might end up with like truncated responses or errors.
Okay.
So being mindful of token usage is really key to crafting efficient prompts.
That's really practical advice. Is there anything else I should be keeping in mind about tokens?
Yeah, the other thing to keep in mind is that tokens actually impact pricing.
Oh, okay.
So OpenAI charges based on the number of tokens you use both in your input prompt and in the generated output.
So it's kind of like you're paying for the amount of thinking the model has to do.
That's a great way to think about it.
That makes sense.
Yeah, being aware of token usage can really help you estimate costs and make sure you're optimizing your API usage.
So tokens are like the currency of the OpenAI world.
Precisely, and understanding that currency is going to make you a much more informed and savvy user.
Got it. Okay, so now that we've kind of covered some of these fundamental concepts, let's actually talk about where to start in the documentation itself.
Yeah,
Because I imagine it can feel pretty dense, especially if you're just starting out.
for sure.
Where would you recommend someone who is brand new to OpenAI and maybe only has a few months of Python experience under their belt? Where should they begin?
I think the quick start section is a really great place to get your feet wet.
Okay.
It gives you this hands-on introduction to using the API. It walks you through actually making API calls, and you get a feel for how things work in practice.
Sounds like a good starting point.
Mm-hmm.
And once you've kind of gone through the quick start, what are some of the essential concepts that every OpenAI user should understand regardless of their project?
So I think understanding the different model types is really crucial. The documentation does a great job of breaking down like the strengths and weaknesses of each model, and that can help you choose the right tool for the job you're trying to do.
Okay.
For instance, if you're working with text, you'll want to dive into the GPT models, while image generation would lead you to DALL-E.
So it's like choosing the right paintbrush for your masterpiece.
Exactly. Each model has its own unique capabilities, and knowing what each one excels at will really help you unlock their full potential.
Now, we've talked a lot about prompt engineering, but what about the actual code?
Yeah.
How much Python knowledge do I really need to get started with the OpenAI API?
So the great thing is the API itself is designed to be super user-friendly.
Oh.
You don't need to be like a Python master to
Yeah.
build really amazing things.
That's good to hear.
Yeah, a basic understanding of functions, variables, and data structures will get you pretty far.
So the 3 months of Python I have under my belt should be enough to get going.
Absolutely. And plus, the documentation is filled with all these code examples, which is like a fantastic way to look.
Oh, that's great.
Yeah, you can see how the code is structured and get a feel for how everything works together.
Yeah, I love that kind of learn by doing approach.
Yeah,
It's so much easier to grasp a concept when you can actually see it in action.
right. It's like having a recipe to follow, when you're trying a new dish.
Exactly.
Yeah.
And then as you become more comfortable, you can start exploring even more advanced techniques like fine-tuning a model to fit your specific needs.
Yeah.
Fine-tuning sounds really powerful, but also kind of intimidating.
Mm.
Can you break that down a little bit more?
Sure, so think of it like tailoring a suit. You start with a well-made garment, but you want it to fit you perfectly, right?
Right.
Fine-tuning is similar. You take a pre-trained OpenAI model and you adapt it to your specific data and the task you want it to perform.
So if I wanted to create a chatbot that was an expert in, say, Renaissance art history, I could fine-tune a language model with a data set of Renaissance art texts.
That's the idea. By fine-tuning, you're essentially teaching the model to become like a specialist in your chosen domain, which can really dramatically improve the accuracy and the relevance of its responses.
So fine-tuning is like giving the model specialized training to make it even better at a specific task.
Precisely. It allows you to leverage the power of those pre-trained models, but still customize them to fit your own unique needs.
That's starting to click for me.
Eh.
Okay, this is all incredibly fascinating, but I have to admit, I'm a little worried about running into errors. I'm
Yeah.
still pretty new to all this, and debugging can be a real pain.
I hear you, but the good news is that the documentation has got your back.
Okay.
There's a dedicated error code section that's incredibly helpful.
Okay, that makes me feel a little bit better.
Yeah, it provides detailed explanations of these common errors along with potential solutions. It's like having a built-in tech support team.
So if I get stuck, I can just head over to the error code section and hopefully find an answer.
Exactly, and as you become more experienced, you'll start to recognize those common errors and know how to fix them really quickly.
That's reassuring to hear. It feels like the OpenAI team has really thought through the whole user experience and provided support every step of the way.
Yeah, they've done a really excellent job of making the documentation as accessible and as helpful as possible.
Okay, so we've covered the practical aspects, but let's talk about something equally important, which is responsible AI usage.
Yes, definitely.
It feels like with all this power comes a lot of responsibility.
A lot.
How does the OpenAI documentation address this?
So it does have a whole section dedicated to responsible AI usage,
Okay.
and it covers topics like bias fairness and the importance of using these models ethically.
So what are some of the potential risks that the documentation highlights?
So one example is the potential for generating content that's biased or discriminatory.
Okay.
If a model is trained on a data set that contains biased information, it might unknowingly perpetuate those biases in its output.
So if you trained a chatbot on a data set of historical texts, and those texts contain like sexist language, the chatbot might start using sexist language itself.
Precisely. It's a really good reminder that these models are a reflection of the data that they're trained on.
Right.
That's why it's so crucial to carefully curate your training data and be mindful of potential biases.
So being aware of data bias is really important. Are there any other ethical concerns that the documentation discusses?
Yeah, another significant concern is the potential for spreading misinformation.
Right.
These models are so good at generating human quality text. It makes it possible to create fake news articles or social media posts that are virtually indistinguishable from real ones.
That's a little bit scary. We're already dealing with so much misinformation online as it is.
It's true, and that's why it's just so crucial to be critical of the information you encounter online, even if it appears to come from a reliable source.
Yeah.
Double-check facts, consider the source's motivation.
It sounds like media literacy is more important now than ever in this age of AI.
Absolutely. We need to be informed consumers of information, and that includes being aware of the potential for AI-generated content to be misleading or deceptive.
So I know OpenAI has safety measures to try and mitigate these risks.
Yeah.
What are some of the safeguards that they mention in the documentation?
So content moderation is one really important measure.
Yeah.
They have systems in place to flag and filter content that violates their usage policies.
Okay.
Things like hate speech or violent content.
So it's kind of like a safety net to catch some of the more blatant misuse.
Exactly. And while it's not foolproof, it's definitely a step toward encouraging responsible use.
Okay.
They also have guidelines for developers, encouraging them to build applications that use their models safely and ethically.
So it's a shared responsibility between OpenAI and the developers who are using their technology.
That's right. OpenAI provides the tools, but it's up to the developers to use them ethically and to think about those potential consequences of their actions.
It's like giving someone a car.
Yeah.
They have the freedom to drive it wherever they want, but they also have the responsibility to follow the rules of the road and to drive safely.
Perfect analogy. And just like with driving, there are consequences for irresponsible behavior.
Well said. So as we continue to explore the OpenAI documentation, I think the key takeaway here is that this technology holds immense power.
It does.
And we need to wield it responsibly.
You got it. These tools are capable of really amazing things, but it's up to us to use them wisely, ethically, and with careful consideration of their impact on the world around us.
What a powerful message. We've covered so much ground already. We've talked about tokens, where to start in the documentation, different model types, fine-tuning, error handling, and responsible AI usage.
It's a
It
lot.
feels like we've built a really solid foundation.
We have, and you should feel confident diving deeper into the OpenAI documentation on your own.
I'm excited to see what I can build.
Yeah.
So it feels like we've covered a lot of ground, from prompt engineering and tokens to different model types and even ethical considerations. Like, is there anything else we should touch on before wrapping up our deep dive into the OpenAI documentation?
Yeah, one more area that I think is worth highlighting, especially because you have a background in Python. The documentation does a great job of explaining how to work with the OpenAI API in different programming environments.
Oh, that's right. I've been so focused on Python, but I know there are other options out there.
Exactly. And so whether you're working in a Jupyter notebook or a Python script or even a web application,
Wow.
the documentation provides clear instructions and code examples to kind of help you get up and running quickly.
So no matter what my preferred workflow is, the documentation has got me covered.
That's the idea. They've made the API super versatile, so you can really seamlessly integrate it into your existing projects or explore new possibilities in all these different environments.
I love that flexibility. It really feels like we've demystified the OpenAI documentation today.
I hope so. We've covered a ton, but, these are those core concepts that will empower you to explore the documentation with confidence and start building some incredible things with OpenAI.
I'm definitely feeling way more confident now than I did before we started. Any final words of wisdom for our listeners as they kind of embark on their OpenAI journey?
Yeah, I would say embrace the journey, stay curious, and remember that learning is an ongoing process.
Yeah.
The OpenAI documentation is constantly evolving, so be sure to check back for updates and new features.
Good advice.
And, most importantly, have fun exploring the possibilities of AI.
That's great advice. Thanks so much for joining me on this deep dive.
Of course, it's been a pleasure.
I'm so excited to see what our listeners create with their newfound knowledge of OpenAI.
Yeah, me too. It's such an exciting time to be working with AI, and I can't wait to see what the future holds.
All right, Python adventurers, today's deep dive is going to be all about the OpenAI documentation.
Sounds good.
And especially for those of you who, like me, have maybe about 3 months of Python experience under your belt.
Yeah.
Imagine the OpenAI documentation as this enormous map, right?
Right.
It's just loaded with information. And honestly, it can be kind of intimidating at first.
It can.
But don't worry, we're here to help you navigate it.
Yeah, we're going to give you the compass and point out the key landmarks so you can find your way around.
Okay, so we're not going to get bogged down memorizing every single function.
No, not at all.
Okay.
It's more about understanding the big picture, the
Yeah.
core concepts, the architecture, the terminology.
Right.
Once you have that foundation, the details will just fall into place much more easily.
That makes sense.
Okay.
So where do we even begin with this mental map?
Well, let's start with the OpenAI ecosystem.
Okay.
Because it's more than just code, right?
Right.
You have organizations billing API keys,
Yeah.
all essential parts of the landscape.
Okay, organizations.
Yeah.
I have to admit that one throws me off a bit.
Okay.
I'm just one person trying to learn, trying to build cool AI projects.
Right.
Why do I need to think about organizations?
That's a great question. Even as an individual user, you're automatically part of an OpenAI organization.
Yep.
It's basically your workspace.
Got it.
That's where your API keys are managed. Usage is tracked. Billing happens.
Ah, billing. Okay, now that's something I definitely want to understand.
Sure.
I've heard stories about people, hitting that $100 usage limit and then getting a surprise bill. Not the kind of surprise I'm looking for.
Definitely not. And that's why understanding billing and setting up usage notifications is crucial.
Okay.
Imagine this. You're in the middle of a project,
Right.
working on something you're really excited about,
Yeah.
and suddenly, boom, you hit your limit right in the middle of a crucial step.
Yeah, that would be a major roadblock.
Right.
So notifications are key.
Yes, very key to avoiding those billing surprises.
Okay, good to know.
You can even set budgets to automatically stop usage when you reach a certain threshold.
Okay.
It's like having a safety net for your spending.
That's reassuring.
Yeah.
So we've got organizations, we've got billing sorted. What about these mysterious API keys I keep hearing about?
Okay, so your API key, think of it as your personal pass to access OpenAI's API.
Okay.
It's what lets your code communicate with OpenAI servers and get those amazing AI responses.
So it's like the key to my AI kingdom.
Exactly. And just like you wouldn't leave the keys to your house lying around,
Right.
you need to keep your API keys safe and secure.
Okay, security is definitely a priority.
Mhm.
What are some practical ways to do that?
Never store your API key directly in your code. That's a big no-no.
Okay.
Instead, use environment variables.
Okay.
They're like secret compartments for sensitive information.
Environment variables it sounds like a lot to learn about security best practices, but it's good to know where to start.
Absolutely. OpenAI provides extensive documentation on security, and we'll definitely point you to those resources later on.
Okay.
For now, just remember, treat your API key like a precious gem.
Okay, I'm picturing a treasure chest,
Okay,
secure and hidden away.
perfect.
So we've got our organization set up. We're mindful of billing and keeping our API keys safe. What's the next landmark on our mental map?
So now imagine you've built a fantastic AI prototype,
Okay,
something really cool.
right.
The next challenge is figuring out how to scale it up,
Oh,
getting it ready to handle real-world traffic and potentially launching it as a real application.
okay, scaling. I
Yeah.
can already feel my brain starting to sweat a little.
Yeah, it's a
This is where things get really complex, right?
Scaling can definitely be a challenge, but it's also incredibly exciting.
Okay.
It's about taking your AI project from a small-scale experiment to something that can handle, real users, real data, and potentially even generate real revenue.
That's a dream, right?
Exactly.
But how do we even begin to think about scaling? Where do we put all this code and data?
So there are two main approaches to scaling:
Okay.
horizontal scaling and vertical scaling. Horizontal scaling is like adding more servers, spreading the workload across multiple machines.
Okay.
Vertical scaling, on the other hand, is about beefing up a single server, giving it more power and resources.
So it's like choosing between having a team of workers or one super-powered worker.
Exactly.
Got it.
Yeah.
But wouldn't adding more servers get expensive really quickly?
It can, especially if you're not careful.
Right.
That's where smart architecture and optimization come in.
Okay.
And there are a ton of tools and services that can help you manage the costs of scaling.
Okay. Tools and services. That sounds promising.
Yeah,
But with so many options out there, how do we even begin to choose the right ones?
that's where understanding your project's specific needs becomes crucial.
Okay.
Are you expecting like a huge surge in traffic right from the start, or will you be scaling gradually?
Right.
What kind of data are you dealing with?
Okay.
These are all factors that will influence your scaling decisions.
So it's not a one-size-fits-all approach.
Exactly.
It's about finding the scaling solution that's right for my specific project. You got it.
Okay. And don't be afraid to experiment.
Yes. Experiment and iterate.
Okay.
You might start with a simpler setup and then scale up as your project grows.
Okay.
The beauty of cloud platforms is that they offer a lot of flexibility.
Flexibility is key. So we've talked about horizontal and vertical scaling. Are there any other strategies we should consider?
Absolutely. One technique that can significantly improve performance and reduce costs is caching.
Caching.
Imagine you're frequently asking OpenAI for the same piece of information.
Yeah.
Instead of making the same request over and over again,
Right.
you can store the response locally in a cache.
So it's like having a cheat sheet.
Exactly.
Okay.
Caching can drastically speed up your application
Right.
and reduce the number of calls you make to the OpenAI API, which can save you money.
That sounds like a win-win, less waiting and lower costs. Who wouldn't want that?
Exactly. And the best part is implementing caching is often easier than you might think.
Okay.
There are libraries and tools that handle a lot of the heavy lifting for you. Okay, caching is definitely going on my list of things to explore. So we're scaling up. We're caching like pros. What's next on our journey through the OpenAI documentation?
Let's talk about something that can make or break a user's experience: latency.
Latency, isn't that just a fancy word for lag?
Yeah,
The
essentially.
thing that makes online games unplayable.
Yeah, it's the same concept. The time it takes for a request to travel from your application to the server and back
Right.
in the context of OpenAI.
Yeah.
Latency is the time it takes for your code to send a request to OpenAI and receive a response.
Okay, so it's all about speed, but why is latency such a big deal in AI?
Imagine you're building a chatbot,
Okay.
and every time a user types a message,
Yeah.
there's a noticeable delay
Oh,
before the chatbot responds.
right.
That's not a great user experience.
Definitely not. It would feel clunky and frustrating.
Exactly. And when it comes to AI applications, high latency can be a deal breaker.
Yeah.
It can make your application feel slow, unresponsive,
Right.
lead to user frustration, potentially even cause them to abandon your app altogether.
Okay, so minimizing latency is key to a smooth user experience.
Very key.
But how do we even begin to tackle this challenge?
One important thing to remember is that most of the latency in OpenAI interactions comes from generating the text,
Huh?
not processing your initial request.
Really, so it's not about my internet speed. It's about the time it takes for the AI model to actually generate the text.
Precisely, and that's why choosing the right model for the job is crucial.
Hmm.
Bigger, more powerful models might seem tempting,
Right.
but they often come with higher latency.
So it's a trade-off, more power, but also more weighting?
Exactly.
Yeah.
Sometimes a smaller, faster model might be the smarter choice,
Okay.
even if it's not as sophisticated.
Right.
It's about finding that sweet spot between power and performance.
That makes sense. So choosing the right model is one way to manage latency.
Yeah.
Are there any other tricks we can use?
One technique that can be really effective is using stop sequences.
Stock sequence.
Think of stop sequences like setting an alarm to wake you up at the right time.
Got it.
You're essentially telling the model, okay, you've generated enough text time to stop.
So we're preventing the model from rambling on
Exactly.
and generating unnecessary text.
And by limiting the amount of text generation,
Yeah,
you can reduce latency and make your application more responsive.
that's clever. So it's all about being strategic with our instructions to the model.
Precisely. And another technique that can be really powerful is streaming responses.
Streaming response.
Instead of waiting for the entire response to be generated
Yeah,
before sending it back to your application,
right.
you can get the answers piece by piece in real time.
Ah, so it's like getting a live feed
Yes.
of the AI's thoughts as it's generating the text.
Streaming can significantly improve the user experience,
Right.
especially for tasks that involve generating long pieces of text,
Okay.
like writing a story or summarizing a document.
Right.
Imagine you're asking for a list of items.
Wait.
Streaming lets you display those items as they come in, rather than making the user wait for the entire list to be generated first.
That makes a lot of sense. It's all about keeping things moving and engaging for the user.
Exactly. And the best part is, implementing streaming is often surprisingly straightforward.
Okay.
The OpenAI library provides built-in support for it, so you don't have to write a lot of extra code.
Okay, streaming is definitely going on my list of things to explore. So we've talked about scaling, caching, and latency. What else should we keep in mind as we navigate the OpenAI documentation?
One crucial aspect that often gets overlooked, especially when moving from prototype to production, is budgeting.
Right, budgeting. I have a feeling this is where things can get a little scary.
It doesn't have to be scary. Understanding how OpenAI pricing works is key to avoiding any surprises.
Okay.
And it's actually quite straightforward.
Yep.
The basic framework is
Yeah.
cost equals the number of tokens used multiplied by the cost per token.
Okay, tokens, those are the building blocks of language that we talked about earlier, right?
Exactly. And the cost per token varies depending on the model you're using.
More powerful models generally cost more per token.
That makes sense. So how do I know how many tokens I'm going to use before I even start a project? Do I have to become a word counting expert?
Not at all. OpenAI provides a handy tokenizer tool
Okay.
that lets you estimate token usage for different text inputs.
Okay.
You can simply paste your text into the tool,
Right.
and it will tell you exactly how many tokens it will use.
That's incredibly helpful. So before I even send a request to OpenAI, I can get a sense of how much it might cost.
Precisely. And remember, experimentation is key.
Okay.
See if smaller models can get the job done for less.
Right.
Sometimes a simpler approach can be just as effective and much more cost-effective.
Right, because those tokens can add up quickly. And let's not forget our friend caching that can help reduce costs too, right?
Absolutely. Caching not only speeds things up, but it can also save you money by reusing those commonly accessed responses. It's a win-win situation.
So we're being mindful of costs. We're caching like pros. What's next on our mental map of the OpenAI ecosystem?
Let's talk about MLOps. MLOps.
It might sound a bit intimidating at first, but it's basically about having a plan for your AI project's entire life cycle, not just the coding part.
Okay, MLOps. I've heard the term, but to be honest, it sounds a bit like something only super advanced AI engineers need to worry about.
It's true that MLOps is becoming increasingly important as AI projects become more complex and sophisticated.
Yeah.
But even for beginners, understanding the basic principles of MLOps can save you a lot of time and headaches down the road.
So it's like having a roadmap for our AI project's journey.
Exactly. And this roadmap includes several key areas.
Okay.
Managing your data,
Got it.
monitoring your model's performance, retraining it when needed, and deploying it smoothly.
Okay. I can see how each of those steps is important, but can you give me a concrete example of how MLOps might play out in a real project?
Sure, let's say you're building an AI-powered image recognition app.
Okay.
You've trained your model on a set of images, and it's performing well in your initial tests.
Right.
But as you start getting more users, you notice that the model's accuracy is starting to decline.
Oh, that would be a problem. Why would the model's performance change like that?
It could be because the new images your users are uploading are different from the ones you used to train the model.
Yep.
Or it could be that the model is starting to drift over time,
Yeah.
meaning its predictions are becoming less accurate as the data it's seeing changes.
Okay, so what can we do to address this issue?
That's where MLOps comes in.
Okay.
By implementing MLOps practices,
Right?
you can set up systems to monitor your model's performance in real time.
Got it.
You can also automate the process of retraining your model on new data, ensuring that it stays up to date and accurate.
That's pretty amazing. So MLOps is like having a team of virtual assistants,
You could say that.
constantly checking on our model
Yeah.
and making sure it's performing at its best.
It's about automating as much of the process as possible so you can focus on the creative and strategic aspects of your AI project.
Okay, I'm starting to see the value of MLOps. Even for someone just starting out with AI, it's like preventative maintenance for my AI project.
Exactly. It's about making sure your project runs smoothly and efficiently from development to deployment and beyond.
So we've covered a lot of ground: organizations, building API keys, scaling latency budgeting, and now MLOps. It feels like we've already climbed a mountain of information.
Yeah.
But is there anything else we need to consider before we even start writing code?
There's one more crucial piece of the puzzle, especially as our projects move into the real world:
Okay.
safety, security, and compliance.
Okay, those are some serious topics. I have to admit, thinking about security and compliance can feel a little overwhelming.
It's understandable to feel that way, especially as a beginner, but it's essential to remember that safety and security are paramount when building AI applications.
Right, because we're dealing with potentially sensitive information, right?
Absolutely.
Hmm.
We need to be mindful of how we collect, store, and use data.
Yeah.
We also need to make sure our applications are secure and protected from malicious attacks.
So it's like building a fortress around our AI projects.
Exactly. And this fortress has several layers of protection.
Okay.
We need to think about data encryption, access control, vulnerability scanning,
Right.
and a whole host of other security measures.
Wow. It sounds like there's a lot to learn about security.
Yeah.
But where do we even begin with all this? It seems like a whole other world.
Don't worry. The good news is that OpenAI provides extensive documentation and resources on security and compliance.
Okay.
We'll definitely point you to those resources later on.
Okay, that's reassuring. It's good to know there's guidance available.
Absolutely. And remember, security is an ongoing process, not a one-time task.
Right.
As you build your AI projects, always be thinking about security and how you can protect your data and your users.
Okay, I'm taking notes on all of this.
Yeah.
So we've covered a lot of ground here, from the OpenAI ecosystem and API keys to scaling latency, budgeting MLOps, and now security and compliance. It's quite a journey.
It is, but remember, we're doing all this before diving into the code. Building this mental model, this roadmap of the OpenAI landscape, will make navigating the actual documentation so much easier.
You're right. It's like having a map before setting off on an adventure. We know the lay of the land, we know what to expect, and we can approach the documentation with confidence, not confusion.
Exactly. And in the next part of our deep dive, we'll start exploring the documentation itself,
Okay.
highlighting key sections, tools, and resources that will be particularly helpful for Python beginners.
I'm excited to keep exploring. It's amazing how much ground we've covered already, and I'm feeling much more confident about tackling the OpenAI documentation now.
That's great to hear. And remember, this is just the beginning of your AI journey. With the right mindset and the right resources, you can achieve amazing things with OpenAI.
Can't wait to see what's next. Thanks for joining us on this deep dive into the OpenAI documentation. We'll be back soon with more insights and practical tips. Stay tuned.
Welcome back to our deep dive into the OpenAI documentation.
I'm ready to keep exploring. It's amazing how much ground we covered before, from setting up our accounts to understanding the importance of security and compliance. Feels like we've already climbed a mountain.
We have, but the good news is the terrain ahead is even more exciting.
Okay.
Now that we have that mental map of the OpenAI ecosystem, we can start diving into the documentation itself.
Okay, I'm intrigued. What's the first landmark we should explore in the documentation?
Let's talk about a concept that's at the heart of how OpenAI works: tokens.
Tokens. I've seen that word pop up a lot, but to be honest, I'm still not entirely sure what they are or why I should care.
That's a great question. Tokens are essentially the building blocks of language that OpenAI uses to process and generate text. Think of them as units of meaning.
Okay.
They can represent words, punctuation marks, or even parts of words.
So when I send text to OpenAI, it doesn't see it as a whole sentence or paragraph. It breaks it down into these individual tokens.
Precisely. And understanding tokens is crucial because OpenAI's pricing is based on token usage.
Okay.
The more tokens you use, the higher the cost.
Okay, that makes sense. But how do I know how many tokens my text will use? Do I need to become a language expert and count them manually?
Thankfully, no OpenAI provides a really handy tokenizer tool.
Oh, yeah?
You can input your text and it'll tell you exactly how many tokens it uses.
That's super helpful.
Mhm.
So before I even send a request to OpenAI, I can get a sense of how much it might cost.
Exactly. And remember, smaller, simpler models often require fewer tokens, which can lead to cost savings.
Right. It's all about finding that sweet spot between power and efficiency. So we've got tokens covered. What about the AI models themselves? I know OpenAI offers a variety, GPT-3 Daily, and probably others I haven't even heard of yet.
You're right, OpenAI offers a whole family of models, each with its own strengths and weaknesses. It's like having a team of specialists, each with a unique set of skills.
Okay, I like that analogy, but
Yeah.
how do I know which model to choose for my project? It feels a bit overwhelming.
It all depends on your specific goals.
Right.
What are you trying to achieve with your project? Are you generating creative text, translating languages, analyzing data, or something else entirely?
Right. It's about matching the model's capabilities to my project's needs. But with so many options, where do I even begin?
The OpenAI documentation has a dedicated section for each model outlining its capabilities, use cases, and limitations.
Okay.
I'd recommend starting there and reading through the descriptions of each model.
Okay, so the documentation is my guide. But what if I'm still not sure which model to choose?
Don't be afraid to experiment. That's part of the fun of working with AI. You can try out different models, play around with different prompts, and see what kind of results you get.
That's actually really encouraging. It takes the pressure off having to make the perfect choice right away. So I pick a model. I start experimenting what's next. I know there's something about parameters and settings.
You're right. Once you've chosen a model, you can fine-tune its behavior using parameters. Think of parameters as instructions you give the model to guide its output.
Okay, instructions for the AI. Can you give me some examples of these parameters?
One common parameter is temperature. It controls how creative or predictable the model's output will be. A higher temperature means more unexpected and creative results, while a lower temperature means more predictable and consistent results.
So it's like turning up the heat on the AI's imagination.
Exactly. And then there's max tokens, which lets you limit the length of the model's response.
Okay.
This is helpful for controlling costs and preventing the model from generating an overwhelming amount of text.
Ah, that makes sense. It's like setting boundaries for the AI, making sure it stays focused on the task at hand. But how do I know which parameters to use and what values to set them to? Seems a bit like guesswork.
It can be a bit of trial and error at first, but the OpenAI documentation provides guidelines and recommended values for each parameter. And remember, experimentation is key. Try out different combinations of parameters and see how they affect the model's output.
Okay, so it's about understanding the parameters, experimenting, and finding what works best for my project. Got it. But isn't there a risk of overdoing it with the parameters? Could I end up confusing the model or making it do something I didn't intend?
That's definitely a possibility. It's important to use parameters thoughtfully and not just throw them in randomly. The documentation can guide you on which parameters are most relevant for different tasks and models.
Right, because too much of a good thing can sometimes be a bad thing, even with AI.
Mhm.
So I've talked about models and parameters. What about that concept we discussed earlier, latency? Does that come back into play here?
Absolutely. Latency is something you need to be mindful of throughout your OpenAI journey, and different models have different processing speeds. Larger, more complex models tend to have higher latency.
So even if I choose the perfect model and fine-tune it with the right parameters, there's still a chance users might experience delays.
It's possible, especially if you're generating a lot of text or dealing with complex requests. But remember, those optimization techniques we talked about earlier, caching stop sequences and streaming those, can all help reduce latency and improve the user experience.
Right, those are like our secret weapons in the fight against lag.
Yeah.
But is there anything else we can do to address latency specifically from a coding perspective?
One important aspect is understanding asynchronous operations.
Okay.
Instead of waiting for each request to complete before moving on to the next one, you can send multiple requests concurrently and then process the responses as they come in.
So it's like multitasking for our code.
Exactly. And this can significantly speed up your application, especially if you're making multiple calls to the OpenAI API.
Okay, asynchronous operations, definitely something to add to my learning list. So we're managing latency, we're optimizing our code. What's next on our exploration of the OpenAI documentation?
Let's talk about something that might not be the most glamorous topic, but is absolutely essential: error handling.
Error handling. That doesn't sound very exciting. I'd rather be building cool AI features.
I hear you, but trust me, robust error handling is crucial for any coding project, especially when working with external APIs like OpenAI. Things can and do go wrong.
Okay.
What happens if your API request fails or if the model returns an unexpected response?
Okay. I'm starting to see why this is important. We need to be prepared for those uh-oh moments. But what does good error handling even look like?
It's about anticipating potential problems and having strategies in place to deal with them gracefully. For example, you can use try except blocks in your Python code to catch errors and handle them appropriately.
Try except blocks. I've seen those before, but I haven't really used them much.
They're incredibly useful for handling unexpected situations. You essentially try to execute a piece of code, and if it raises an exception and error, you can catch it and handle it in a way that prevents your application from crashing.
So it's like having a safety net for our code.
Exactly. And when working with OpenAI, you'll want to check for specific error codes that the API might return. The documentation provides a list of these error codes and what they mean, which can help you troubleshoot problems more effectively.
That sounds incredibly helpful.
Yeah.
I'm definitely going to bookmark that section of the documentation.
I
So
know.
we're catching errors, we're handling them gracefully. What's next?
Let's shift our focus from the code itself to the environment where our code will live, deployment environments.
Deployment environments. Is this where we finally start talking about servers and cloud platforms? It sounds a bit intimidating.
It can be, but it's also incredibly exciting. This is where you take your AI project from your local machine and make it accessible to the world.
All right, so it's not enough to just have the code working on my laptop. I need to actually put it somewhere where other people can use it.
Exactly. And there are a lot of options for deployment, each with its own pros and cons.
Mm-hmm.
You could use a cloud platform like AWS, Google Cloud, or Azure,
Okay.
or you could set up your own server if you have specific needs.
So many choices.
Hmm.
How do I even begin to choose the right deployment environment for my project?
It comes down to several factors: cost, scalability, security, and the specific tools and services offered by each platform.
Okay, so I need to do my research and carefully consider my project's requirements before jumping into deployment. But what about interacting with the OpenAI API once my project is deployed? How does that work?
That's where API endpoints come in.
API endpoints, I feel like we're entering a whole new layer of the OpenAI onion.
Think of API endpoints as specific doorways into the OpenAI system.
Okay.
Each endpoint provides access to a particular functionality, like generating text, creating images, or translating languages.
So it's like having different doors for different tasks.
Precisely when you send a request to OpenAI, you need to specify the endpoint you want to use. This ensures that your request is routed to the correct part of the system and processed appropriately.
Okay, so it's all about being specific and telling OpenAI exactly what we need it to do. But how do I know which endpoint to use for a particular task?
The documentation provides a comprehensive list of API endpoints along with detailed explanations of what each endpoint does and how to use it. It's like a menu of all the amazing things you can do with OpenAI.
That sounds incredibly helpful.
Lovely.
I'm starting to feel like I'm actually getting the hang of this.
Yeah.
It's less intimidating than I thought it would be.
That's great to hear. And remember, the documentation is your best friend throughout this journey.
Right.
Don't be afraid to refer to it. Often search for specific keywords and even experiment with different endpoints to see how they work.
Experimentation. That's the key, right? It's how we learn and discover new possibilities. And speaking of possibilities, I'm eager to start actually writing some code and seeing these AI models in action.
I know, me too. And in the next part of our deep dive, we'll do just that. We'll delve into some practical examples and tips for using the OpenAI API with Python. Get ready to see those AI models come to life.
I can't wait.
Oh.
This is where the real fun begins. Stay tuned, everyone. Welcome back to the final part of our deep dive into the OpenAI documentation.
It's been quite a journey so far. We've built our mental roadmap, explored key concepts, and now it's time to, roll up our sleeves and start writing some code.
I'm so excited to see how all this theoretical knowledge translates into actual Python code. I have to admit, I've been itching to get my hands dirty and actually start building something.
I hear you. There's nothing quite like seeing those AI models come to life in your own code. But before we jump into the specifics, let's just take a moment to appreciate how user-friendly the OpenAI Python library is, even for beginners.
Okay, user-friendly is always a good thing, especially when we're talking about something as potentially complex as AI. But where do we even begin? How do we install this library and get it ready to use?
It's surprisingly simple. You can use pip, the package installer for Python. Just open your terminal or command prompt and type pip install OpenAI. That's it.
Wow, that's so easy. No complicated setup or configuration files.
Nope. The OpenAI team has done a great job of making the installation process as smooth as possible.
That's great to hear. So now that we have the library installed, what's the first step in actually interacting with the OpenAI API?
The first step is authentication. Remember that precious API key we talked about earlier? This is where it comes into play. You need to tell the library where to find your key so it can authenticate your requests.
Right, the API key, it's like our backstage pass to the OpenAI world.
Exactly. You can set your API key as an environment variable, or you can pass it directly to the library when you initialize it. The documentation provides clear instructions on both methods.
Okay, I'm going to make sure my API key is securely stored as an environment variable.
Yeah.
So once we're authenticated, what's next? How do we actually start using these AI models?
Let's say you want to generate some creative text using the GPT-3 model. You would use the OpenAI.completion.create function.
Okay, OpenAI.completion.create. It sounds promising, but what goes inside those parentheses? What do I need to tell the model to get it to do what I want?
This is where you provide the model you want to use the text prompt that serves as the starting point for the generation, and any additional parameters you want to set, like temperature or max tokens. Remember those parameters we discussed earlier?
Right, the parameters, it's like giving the model its instructions and setting the stage for its creative performance.
Exactly. And what's really cool is that the OpenAI library handles all the complexities of sending the request, receiving the response, and parsing the data. You don't have to worry about the low-level details of HTTP requests and JSON formatting.
That sounds incredibly convenient, so I can focus on crafting my prompts and experimenting with different parameters without getting bogged down in the technical nitty-gritty.
Precisely, the library abstracts away a lot of the complexity, making it easier for you to focus on the creative and strategic aspects of working with AI.
That's a huge relief.
Yeah.
It makes AI feel much more approachable and accessible, even for someone like me who's still relatively new to Python.
And as you become more comfortable with the basics, you can explore more advanced features like fine-tuning models with your own data or using embeddings to perform semantic search.
Whoa, hold on. Fine-tuning and embeddings, those sound like advanced AI magic. I'm not sure I'm ready for that level of complexity yet.
Don't worry, you don't have to dive into those advanced concepts right away, but it's good to know that they're there waiting for you when you're ready to take your AI skills to the next level. And the OpenAI documentation provides excellent guides and tutorials on these topics. They're like treasure maps leading you to even more powerful capabilities within the OpenAI ecosystem.
Okay, I'm adding those to my reading list for the future. But for now, let's focus on mastering the basics. Are there any tips or tricks you can share for beginners who are just starting out with the OpenAI API?
Absolutely. First, don't be afraid to experiment. Try different models, tweak parameters, and see what happens. The more you play around, the more you'll understand the nuances of each model and how to get the best results.
That's great advice. It's all about learning by doing.
Second, read the documentation carefully. It might seem obvious, but the documentation is your best friend. It contains a wealth of information, explanations, and examples that will guide you every step of the way.
Right, it's like having a personal AI tutor available 24/7.
And finally, don't be afraid to ask for help. There's a vibrant and supportive OpenAI community online with forums, Discord servers, and social media groups where you can connect with other developers, share your experiences, and get answers to your questions.
That's fantastic.
Yeah.
It's a reminder that we're not alone on this AI journey.
Exactly. The AI community is incredibly welcoming, and collaborative people are always willing to help each other out and share their knowledge.
That's really inspiring and makes me even more excited to be part of this world.
So as we reach the end of our deep dive, I want to commend you for taking this journey with us. You've shown a genuine curiosity and a willingness to explore the exciting world of OpenAI.
I have to say, I feel like I've gained a whole new perspective on the OpenAI documentation. It's no longer this mysterious and intimidating black box. It's more like a well-organized toolbox filled with powerful tools and clear instructions on how to use them.
That's a great way to put it. And with the knowledge and tools we've discussed, you're well equipped to embark on your own AI adventures. Remember, the only limit is your imagination.
That's so inspiring. I'm feeling so much more confident about diving into the code and starting to build my own AI-powered projects. Any final words of wisdom before we wrap up?
Just this: keep learning, keep experimenting, and keep pushing the boundaries of what's possible with AI. The future is incredibly exciting, and you're now part of shaping it.
I can't wait to see what the future holds. Thanks for joining us on this deep dive into the OpenAI documentation. Until next time, happy coding. All right, let's dive in. Today we're tackling the OpenAI documentation, and I know I know documentation might not sound super thrilling, but trust me, we're going to make this fun. We're going to think of you, the listener, as someone who's just getting started with Python, like 3 months in, and you're ready to conquer OpenAI, but maybe a little intimidated by those docs, right?
Yeah, that's where we come in. We're here to help you build that mental roadmap before you even crack open the docs. It's like having a blueprint before you start building. You wouldn't just start slapping bricks together without a plan.
Exactly. And speaking of plans, when I first peeked at the OpenAI documentation, the section on safety best practices really jumped out at me. I was kind of surprised to see that front and center, but also really intrigued.
That's actually a really smart starting point. When you're dealing with powerful AI models, safety has got to be foundational. It's not something you tack on at the end. It's got to be baked in from the beginning.
Okay, I'm hearing safety first. I like that. But what does that actually look like for someone who's just starting out with Python? What are the practical steps?
Well, one concept they emphasize is red teaming. It's kind of like putting on your hacker hat and trying to break your own application, but like with good intentions. The goal is to find those weaknesses before they become real world problems.
So like I'm building a chatbot and I'm thinking, okay, how do I red team this thing? Give me an example of a weakness I might totally overlook as a beginner.
Let's say you're not properly validating user input. Someone could enter some malicious script into your chatbot, and without the proper validation, your bot could actually execute that script and potentially cause some harm.
Yikes. Definitely don't want that. So what are the tools or techniques I can use to validate that user input and make sure things don't go haywire?
Well, OpenAI actually has this really handy moderation API, and it's kind of like having a security guard at the door checking for anything suspicious before it gets through. It can help detect and filter out like potentially harmful content.
That makes sense. It's like a safety net, catching those errors before they cause any real trouble. But even with this moderation API, I still feel a little uneasy about just letting AI run wild.
I hear you, and that's why OpenAI really stresses this human in the loop approach. It's kind of like having a pilot on autopilot, right? Like the AI can handle a lot, but you, the human, are ultimately in control, especially in those critical situations.
Okay, that's reassuring. So I'm not just blindly trusting the AI, I'm working with it. But let's be honest, as a beginner, how can I even make sure the AI is actually doing what I want it to do?
That, my friend, is where the magic of prompt engineering comes in. It's all about crafting those instructions to the AI in a way that gets you the best and the safest results. It's an art, really.
Prompt engineering. Okay, that sounds kind of fancy. Can you break that down for me? Like, what does that actually look like?
Okay, so imagine you're asking the AI to write a poem. If you just give it a vague prompt like, write a poem about love, you're probably going to get back something pretty generic, right? But if you're more specific, like, write a sonnet about unrequited love in the style of Shakespeare, now you're talking, you're much more likely to get something unique and interesting.
So it's all about being precise,
Yeah.
giving the AI really clear guidelines to follow. Makes sense. But what about the technical side? How do I actually implement these prompts in my Python code?
It's actually simpler than you might think. It's basically like writing a function, right? You're providing the AI with an input in the form of a text string, that's your prompt, and the AI processes that and spits back an output, which is also a text string. It's all about sending and receiving text, which you're already familiar with from your Python experience.
Oh, okay. So I'm interacting with the AI through these text strings. That's way less intimidating than I thought.
Right. And once you're comfortable with the basics, then you can start exploring more advanced prompt engineering techniques, using specific keywords or even formatting those prompts in a certain way to really guide the AI's output.
This is already starting to feel like a roadmap, a way to navigate the OpenAI documentation without getting totally lost. I'm less focused on like the individual lines of code and more on the bigger picture of how it all fits together.
And that's exactly the point. Now, let's shift gears for a sec and talk about something you might not expect to see like a programming doc, know your customer, or KYC.
Wait, KYC, isn't that something like banks use? Why is that relevant to me as, someone writing Python code?
It really highlights that building AI isn't just about the code, it's about the people who are going to be using it.
Oh, so it's about thinking about the user experience, making sure my AI is safe and accessible for everyone.
Exactly. And the OpenAI documentation has some really practical tips for this. Like, for example, they talk about limiting how much text a user can input, which can help prevent something called prompt injection. That's where someone tries to, trick your AI with malicious instructions.
So instead of having a giant open text field, I might use Like a drop-down menu with pre-approved options.
Exactly. It's all about minimizing the potential for misuse. Even something as simple as connecting user actions to an existing account, like their Gmail, can add a layer of accountability.
That's interesting. It's like those login with Facebook buttons you see everywhere. It's not just for convenience, it's for security too.
Absolutely. And one more thing, think about providing a clear way for users to report issues. Not only does this help you improve your application, but it also builds trust. Users feel heard, and they know you care about their experience.
I'm seeing a pattern here. A lot of these safety best practices are actually just good development practices in general, whether I'm building AI or like a simple website.
You're absolutely right, and that's what makes these guidelines so valuable. They're not just about AI, they're about building robust, user-centered applications.
This is all making me feel so much more confident about actually tackling those OpenAI docs. It's like having a guide, a mentor, whispering in my ear, hey, here's what to look out for, and here's how to think about this.
And that's just the beginning. As you progress, you'll uncover even more layers of complexity and nuance. All right, welcome back to the deep dive. Let's jump right back into where we left off, exploring how OpenAI's guidelines can help us create AI applications that are not only effective, but also responsible and secure.
Yeah, we covered a good deal about safety in the last part, but I'm ready to go even deeper to get a real handle on how to protect my AI and the people who are using it.
That's the spirit. And that brings us to the next critical level, security. You can think of it as building a digital fortress around your AI to make it resilient against attacks and misuse.
Okay, I like the fortress analogy. What would you say are the building blocks of this digital defense?
Well, authentication is one of the first lines of defense. OpenAI really emphasizes the importance of having users create accounts and log in to use your AI application.
Makes sense. It's like having a gatekeeper, right? Making sure that only authorized users can get in. But, for a beginner like me, the idea of building a secure login system from scratch can feel, well, a little daunting.
A lot of people feel that way, and that's why OpenAI actually suggests a pretty clever shortcut. Instead of building it all yourself, try linking user accounts to existing trusted services like Gmail or Facebook.
Oh, you mean like those login with Google buttons you see all over the place? So basically, I can leverage the security measures that those big platforms already have in place.
Precisely. It's a smart move because you're essentially piggybacking on an established security infrastructure. And for applications that deal with really sensitive information like finances or personal data, OpenAI even recommends considering credit card or ID verification.
Wow, that's serious stuff. It really shows how much they prioritize security. But, okay, let's say I've built my fortress walls, my users are logging in securely. What are some other, sneaky threats that I should be aware of?
One of the biggest dangers is something called prompt injection. Remember how we talked about prompt engineering in the last part, about carefully crafting instructions for the AI? Well, prompt injection happens when someone tries to sneak in instructions that are malicious or harmful.
Ooh, that sounds sneaky. Can you give me, a concrete example of how that could happen?
Sure. Imagine you've built a chatbot that can help people with coding, right? A user could type in a prompt that looks harmless but actually contains hidden commands to access your system files, or maybe even steal sensitive data.
Oh man, that's a scary thought. It's like someone hiding a virus inside a file that looks totally innocent. So how do I prevent something like that from happening?
OpenAI offers a few smart tactics. One of the simplest but most effective is limiting how much text a user can put into the prompt.
So instead of having a giant open text box, I might restrict it to a certain number of characters or words, right? Sort of like putting a limit on a tweet.
Exactly. By shrinking that input field, you're basically reducing the space where those attacks can hide. It's like making the entrance to your fortress a little bit smaller, making it tougher for those attackers to slip in.
Small entrance, big security. I like it. So what are some other strategies for safeguarding my AI?
Another really powerful technique is to ditch those open-ended text boxes altogether. Instead, think about using things like drop-down menus or predefined options.
Oh, I see. So instead of letting users just type whatever they want, I give them a curated list of choices, kind of like a multiple choice quiz.
Precisely. That way, you have more control over what kind of input goes into your system and prevent any unexpected or harmful commands from sneaking in. It's like offering a set menu at a restaurant instead of letting people just shout out random food orders. Way more controlled, a lot less chaos.
Definitely less chaos. I'm starting to see that building secure AI involves a lot of thinking ahead, anticipating those potential problems before they even pop up.
That's the key. And OpenAI suggests taking control of the output side as well. They recommend setting limits on how many output tokens the AI can produce.
Output tokens. Remind me what those are again.
Think of tokens as the building blocks of text. They could be words, punctuation marks, or even parts of words. By limiting the number of tokens, you're essentially preventing the AI from rambling on and potentially generating irrelevant or even risky content.
So it's kind of like putting a word limit on an essay. Keep things concise and on point.
Exactly. And this ties back into security, too. Someone with bad intentions could try to overload your AI with a super long prompt, causing it to crash or become unresponsive. But by setting those token limits, you're putting up a safeguard against those kinds of attacks.
It's amazing how much thought goes into building secure AI. It's not just about writing the code, it's about all these extra layers of protection.
You're right, it's multifaceted. And there's one more crucial layer that we need to add, and that's data validation. It's like making sure that all the ingredients you're using to bake a cake are fresh and not contaminated.
Okay, I like that. Bad ingredients, bad cake. So in the context of AI, what does data validation actually involve?
Well, there are a few techniques. One of the most important is narrowing down your data sources. It's a good idea to stick with trusted and reliable sources whenever you can.
So instead of letting my users input any random website URL, I might restrict them to a pre-approved list, kind of like a curated library of information.
You got it. By being selective about your data sources, you can reduce the risk of introducing information into your AI system that might be biased, inaccurate, or even malicious.
Makes sense. Especially if you're dealing with sensitive stuff like personal information or financial details. You definitely don't want any iffy data creeping in.
Absolutely. And OpenAI suggests techniques like input sanitization, which is kind of like running a security scan on all the data before you allow it into your AI fortress. It's all about removing potentially harmful characters or code that could mess things up.
So it's like a multi-pronged approach. Secure the entry points, control the output, and sanitize the data, like having a comprehensive security checklist.
You nailed it. By taking all of these security best practices to heart, you're not just building any AI application, you're creating a system that's secure, trustworthy, and something that your users can rely on.
This is really eye-opening. I'm starting to realize that security isn't just this, technical hurdle to overcome. It's actually a fundamental part of being a responsible AI developer.
You're absolutely right. And in the next part of our deep dive, we're going to build upon this foundation and explore how transparency plays a huge role in building trust and making sure that AI is used ethically.
Welcome back to the deep dive. We've built our digital fortress. We've got all those security protocols in place. Now I'm ready to zoom out a little and really explore the why behind it all.
Yeah, I mean, it's not enough to just build AI that works. It's got to work in a way that benefits society and aligns with our values, right?
Okay, so we're talking big picture stuff here, the ethical considerations. But honestly, as a beginner, sometimes I'm so focused on just getting the code to work that it's hard to think about the impact of what I'm building.
I totally get it. And OpenAI really emphasizes that this is a journey, right? It's not like you reach this perfect state of ethical AI development. It's a constant process. So start by just asking yourself, what happens when I release this out into the world? Think about both the good and the bad.
So let's say I build a chatbot that can write really persuasive marketing copy that could be used to promote an awesome product, but it could also be used to trick people into buying things they don't need.
Exactly. And those are the kinds of ethical dilemmas that developers are having to grapple with more and more. OpenAI really wants us to think about these issues before we hit that publish button.
It's like that classic line, right? With great power comes great responsibility.
Totally. And that responsibility extends beyond just our own individual actions. OpenAI highlights the importance of community, working together to figure out the norms and the best practices for the whole field.
So like sharing knowledge, learning from each other's mistakes, and figuring out how to use AI for good as a team.
Precisely. They have forums and resources specifically for that, and it's so cool to see developers from all over the world coming together to discuss these complex topics.
Okay, so community is important. I got it. But let's be real. A lot of us are just starting out. We're excited to build cool things. So how do we balance that enthusiasm with this, sense of responsibility? It can feel a little overwhelming.
It definitely can. I think the key is to not let the big picture freeze you up. Pick a project that excites you and at each step, ask those why questions.
So not just how do I code this feature,
Mm-hmm.
but also what could be the impact of this? the good and the bad.
Exactly. Make those ethical considerations part of your process. Bake them right into your workflow.
This is like totally changing how I think about coding. It's not just about like solving puzzles anymore. It's about making choices that have real world impact.
And that's a pretty awesome feeling, right? Knowing that as developers, we have this unique opportunity to shape how AI is used.
Okay, so I'm definitely on board with the whole responsible AI thing. I'm
Yeah.
thinking about impact. I'm engaging with the community. What are some practical things I can do like right now to make a difference?
One of the most powerful tools we have is our voice. Talk about these issues. Share your experiences, both the good and the and challenging stuff, with other developers. Write blog posts, give talks, participate in forums, all of that.
So even if I'm not building like the next groundbreaking I can still contribute to the conversation and help shape the ethical landscape.
100%. Every voice matters. The more we talk about these things, the more likely we are to find solutions that work for everybody.
That's really encouraging. It's a call to action, but also a reminder that we're not in this alone. There's a whole bunch of people out there wrestling with these same questions.
Exactly. And that's what makes it so exciting. It's not just about the tech, it's about humanity. It's about using our skills to build a better future.
Wow. What an incredible way to wrap up this deep dive. I came in feeling a little intimidated by those OpenAI docs, but now I feel like really inspired.
That's awesome to hear. And remember, those docs are just a starting point. There's a whole world of AI knowledge waiting to be explored.
And to all our listeners out there, keep learning, keep asking questions, and keep building awesome stuff. You never know, you might just be the one to create the next big AI breakthrough.
Until next time, happy coding.
All right, Python explorers, get ready to conquer the OpenAI documentation. We know you're about 3 months into your Python journey, and the OpenAI docs can seem like a bit of a jungle at first. But don't worry, we're here to be your guides. In this deep dive, we're not going to spoon-feed you every single detail, but we'll give you the mental map you need to navigate the documentation with confidence.
That's right. We're going to break down the jargon, the key concepts, even the way the whole system is structured. And by the end of this, you'll be able to open those docs and actually understand what you're reading.
And speaking of understanding, there's this awesome feature called prompt caching that I'm super excited about. It can actually make using the OpenAI API cheaper and faster. Imagine cutting your API bill in half and getting results in seconds instead of minutes. That's the kind of power we're talking about.
Prompt caching is a real game changer, especially as you start building more complex applications or using the API more frequently. It works by automatically storing parts of your prompts, which are basically the instructions and examples you give the model. So let's say you're always asking it to summarize news articles. The system will remember those instructions and even how you like your summaries formatted.
So it's like the AI is learning from my past requests and getting smarter over time. That's kind of mind-blowing.
Exactly. And the next time you ask for a summary, it doesn't have to start from scratch. It can reuse those calculations, leading to faster responses and lower costs.
Whoa, that's way simpler than I thought it would be. And I don't even have to write any special code for this.
Nope, it's all happening behind the scenes automatically. OpenAI has taken care of all the heavy lifting for you.
That's a huge relief.
Yeah.
But I'm guessing there are some things we can do to make sure we're getting the most out of this caching magic, right?
You bet. The way you structure your prompts is key. Think of it like this. Imagine your prompts are like sentences. You want to put the unchanging information like the instructions, summarize this news article at the beginning, just like the subject of a sentence. And then the variable stuff, the actual news article you want summarized, goes at the end, like the object of the sentence.
Okay, so I'm starting to see the pattern here. It's all about being organized and thinking about what parts of my prompts are going to stay the same versus what will change each time.
Precisely. It's like having a well-organized toolbox. You keep the tools you use most often right at the front, easy to grab. The more you can front-load those common instructions, the higher the chance of a cache hit. That's when OpenAI finds a match in its memory and can reuse those calculations, saving you time and money.
Got it. But how does the system know how much of my prompt to cache? Does it work with any length?
Well, caching kicks in for prompts that are 124 tokens or longer. Now, you might be thinking, what in the world is a token? Tokens are like the building blocks of language that OpenAI understands. Think of them as word fragments. The longer your prompt, the more tokens it has, and the more potential there is for caching.
Okay, that makes sense. So longer prompts generally mean more opportunity for caching. But what if my prompt is longer than 124 tokens? Does just cache the first 1024?
It's a bit more nuanced than that. Cache hits happen in chunks of 128 tokens. Imagine it like loading a progress bar as more chunks of your prompt get cached. The loading gets faster and faster.
So the longer my prompt and the more chunks that get cached, the faster and cheaper things become. Is there a way for me to actually see this happening in real time, to know if I'm getting those cache hits?
Absolutely. In the API response, there's a field called cache tokens. This tells you exactly how many tokens were pulled from the cache for that particular request. So you can actually track how well you're doing with your prompt structuring.
That's really cool. It's like having a scorecard for how efficient your prompts are. But before we get too deep into that, I'm curious about what kinds of things can be cached. Is it just the text of my prompts, or can other elements be stored as well?
It's definitely not just text. The system can actually cache your entire conversation history. The system messages your messages and the assistant's responses. It can also cache images, whether they're included as links or in that base64 format you might have encountered.
Wait, hold on. Images too. That's wild. I had no idea you could even use images with the OpenAI API, let alone cache them.
It's pretty amazing what you can do with the API these days. And it can even handle multiple images in a single request. But remember, for images to be cached, they have to be identical between requests.
So it's not just remembering what I said, but what I showed it. That opens up so many possibilities. What else can be cached?
Well, we are getting into slightly more advanced territory here, but the system can also cache the tools you want the AI to use.
Tools. Okay, now you've officially lost me.
Yeah.
What do you mean by tools in this context?
Good question. Let's say you're building a chatbot that can access real-time stock prices. That access to real-time stock data, that's a tool the AI can use. And if you're consistently asking for stock prices, caching that tool means the AI doesn't have to relearn how to access that data every single time.
Ah, I see. So it's like giving the AI a specialized skill set that it can access more quickly thanks to caching. Makes sense.
Exactly. And one last thing you might encounter down the road, the system can also cache structured outputs. This is a way to define how you want the AI to format its responses.
So if I'm always asking for the output in a JSON format, it can remember that preference.
You got it. We won't go too deep into structured outputs right now, but if
Yeah.
you come across that term in the documentation later on, you'll have a head start.
Awesome. I love having these little nuggets of knowledge in my back pocket. Okay, so we've covered what prompt caching is, how it works, and what it can store. Now let's talk strategy. What are some best practices for making sure we're squeezing every drop of efficiency out of this feature?
Well, we touched on the most important one already, structure your prompts effectively. Keep that static content at the beginning and the dynamic content at the end.
Right, like writing a good sentence. What else? I feel like this is where things could get tricky for someone just starting out with Python.
You're right, it's easy to get overwhelmed. Another tip is to start with longer prompts if possible. Remember, caching kicks in at 10,024 tokens, so the sooner you hit that threshold, the sooner you start benefiting.
So even if I could technically achieve something with a shorter prompt, it might actually be more efficient in the long run to make it a bit longer and take advantage of caching.
Exactly. It's about finding that balance. And another great practice is to think about typical user interactions. If you're building a chatbot, are there certain instructions or greetings you'll always use at the beginning?
Right, like setting the stage for what the chatbot can do.
Exactly. By front-loading those common elements, you're increasing the likelihood of those cache hits and making interactions much faster.
It's all about planning ahead and anticipating those patterns. I like it.
And finally, this applies to any development work. Really keep an eye on your metrics. The OpenAI API gives you data on response times and costs. Seeing those numbers improve as you optimize your prompts is a great motivator.
It's like a game, trying to beat your high score for efficiency. Okay, so prompt caching sounds incredibly powerful, but I'm sure some listeners might have some concerns. Like, what about privacy? We are essentially giving OpenAI access to our prompts, right?
That's a valid concern, but the documentation is very clear on this point. Prompt caches are not shared between organizations. Your prompts, your data, it's all kept safe and sound within your own organization.
Okay, that makes me feel better. But what about the AI's responses? If it's reusing calculations, could that lead to different or less accurate results?
Not at all. Prompt caching only affects the speed and cost of processing the request. It has absolutely no impact on the AI's response. The AI's reasoning and decision-making process remain completely untouched.
So whether the system uses the cache or processes the whole thing from scratch, I'm getting the same quality output.
Got it. Now I'm thinking about all those cached prompts piling up. Do I need to clear them out manually?
You don't have to worry about that at all. OpenAI has designed the system to be self-cleaning. Prompts that haven't been used recently are automatically removed from the cache.
So no cache clutter to worry about. That's relief. Speaking of things to worry about, is there any extra cost associated with prompt caching?
Nope. It's built right into the system, it's automatic, and there are no additional fees. Consider it a free perk from OpenAI to make your development life a bit easier.
I love free perks. Okay, last question on the concern front. Do those cached prompts still count towards my API usage limits?
Good question, and yes, they do. Caching doesn't give you a free pass to bypass those rules. You're still using the API, you're just using it more efficiently. Right, that makes sense. It wouldn't be very sustainable for OpenAI to let people go crazy with API calls just because they're using caching effectively. Speaking of usage, the documentation mentions something called scale tier and zero data retention. Do those interact with prompt caching in any way? Okay, I'm curious about those. Can you give us a quick rundown?
Sure. Scale tier is basically a higher level of service from OpenAI that offers more features and flexibility. And yes, prompt caching is available on scale tier. Any tokens that spill over to the shared API from scale tier are also eligible for caching.
So if I'm using scale tier, I get all the benefits of prompt caching plus some extra goodies.
Got it. What about zero data retention?
Zero data retention is a super strict privacy setting that lets you prevent OpenAI from storing any of your API data. And the cool thing is, even with zero data retention enabled, prompt caching still works its magic. Wow. So even when you're taking extra measures to protect your data, you can still benefit from caching. That's really impressive. I think we've covered pretty much all the bases here. For our listeners who are ready to tackle the OpenAI documentation, what's the key takeaway they should keep in mind about prompt caching?
I think the most important thing to remember is that prompt caching is your friend. It's there to make your life easier, your applications faster, and your wallet a bit happier.
It's like having a secret weapon in your coding arsenal.
Yeah.
And the best part is you don't have to be an AI expert to use it. Just by understanding the basics we've discussed, how to structure your prompts, effectively thinking about those common elements, you can front load. You can start reaping the benefits.
Exactly. I'd encourage everyone listening to open up the documentation now, maybe even have it open alongside this episode. Start experimenting, see prompt caching in action, and watch those cache tokens numbers climb. You'll be amazed at how much of a difference it makes.
I love that challenge. And you know me, I always like to give our listeners something extra to ponder. So here's my challenge to you. Think of a real-world task that you could automate or simplify using the OpenAI API. Could be anything, summarizing documents, translating languages, brainstorming ideas. Let your imagination run wild.
That's a great idea. As you're designing your application, think about those prompts from the very beginning. How can you structure them to take full advantage of prompt caching? Remember, those small optimizations can make a big difference in the long run.
It's all about working smarter, not harder. And who knows, maybe we'll feature some of your awesome OpenAI creations on a future deep dive. We're always excited to see what our listeners are building.
We're here to support you on your OpenAI journey every step of the way.
Thanks for joining us for this deep dive into prompt caching. We'll catch you next time for another fascinating exploration of the world of AI. Hey everyone, and welcome back to the deep dive. Today, we're going to be tackling something that can feel like a bit of a hurdle for folks who are starting out with Python and AI, and that's the OpenAI documentation. Specifically, we're thinking about you, the person with about 3 months of Python under their belt, eager to build cool stuff, but maybe a little intimidated by, those dense docs.
You can think of this deep dive as like a pre-flight checklist. We're going to map out the territory, we'll decode some jargon, and by the end, you'll feel ready to explore the OpenAI docs with confidence. Not confusion.
I love that. And to make this super practical, we're going to focus on one key decision you'll face pretty early on, and that's understanding the differences between OpenAI's reasoning models and the GPT models.
Yeah.
Kind of like picking the right tool from a superpower toolkit, which can be a little overwhelming at first.
Yeah, absolutely. And the key is understanding that neither model family is inherently superior. They excel in different areas, kind of like a master strategist versus a highly efficient workhorse.
Ooh, I like that analogy. Can you unpack that a bit more? What makes the reasoning models the strategic masterminds?
So reasoning models, like those in the O series, are built for deep, methodical thinking. They shine when dealing with complex or ambiguous problems, almost like a detective, piecing together clues. They can analyze massive data sets, spot those subtle connections, and even ask clarifying questions if the information is unclear.
Whoa, hold on. They can ask questions. That's like next level. So while the reasoning models are pondering the big picture, what are the GPT models up to?
Think of GPT models as like the workhorses built for speed and efficiency. They're amazing at following very clear instructions and executing well-defined tasks, like summarizing text, translating languages, or even generating some creative content. They might not be the strategic masterminds, but they get stuff done, quickly and cost-effectively.
Gotcha, so I'm starting to see the difference here. But let's get concrete. Could you give us some real-world examples of when you'd pick one model over the other?
Sure. Imagine you're building an e-commerce platform. A GPT model could rapidly process customer orders, flag potential returns based on simple rules. But for that final decision, taking into account things like customer history, item value, and company policy, you might turn to a reasoning model for that nuanced judgment call.
That's a really helpful example. So it's almost like a tag team approach.
Hmm.
GPT for speed, reasoning for accuracy when it really matters. Are there any other scenarios where this plays out?
Absolutely. Let's say you're dealing with dense legal documents. A GPT model could help to summarize key points, but a reasoning model could dissect those documents. It could flag potential risks buried deep within the text, and even connect the dots between multiple documents to reveal a bigger picture that a simple summary might miss.
Okay, now those needle in a haystack skills are making a lot more sense. It's almost like they're running an in-depth analysis in the background, while that GPT model gives us the quick initial overview.
Exactly. And this difference in approach comes down to how these models are built. Reasoning models often employ sophisticated algorithms and techniques to deeply understand and interpret the data they're given, while GPT models are more focused on generating text based on patterns and relationships they've learned from massive data sets.
That makes a lot of sense. It's like they have different thinking styles, each suited to different tasks. Now, for our listener who's just starting out, how do they go about choosing the right model for a project? It's easy to feel overwhelmed, with all those options.
You're right, it can be a bit like standing in front of a massive ice cream counter. But a good starting point is to consider a few key factors. First, speed and cost. If those are your top priorities, GPT models often win. They're designed for quick, efficient processing.
Okay, so if I'm on a tight budget and deadline, GPT is probably my go-to. What if accuracy and reliability are paramount, though?
Then reasoning models are your best bet. They're built to be meticulous, especially in high-stakes situations. They excel at tasks where even a small error could have significant consequences.
Got it. So reasoning models when the stakes are high, GPT models when I need speed and efficiency. But what about those situations where there's a lot of ambiguity, like you mentioned with the legal documents? How do I know which model can handle that complexity?
That's where reasoning models really shine, complex problem solving. They're built to navigate uncertainty, make connections between disparate pieces of information, and even ask clarifying questions if needed. Think of them as like the AI detectives digging deeper to get to the truth.
I have to admit, that's pretty impressive. It's like they have a built-in sense of curiosity and critical thinking.
Exactly. And this ability to handle ambiguity comes from their underlying architecture and training data. They're exposed to a wider range of scenarios and learn to reason more flexibly than GPT models, which are often trained on more specific and structured data sets.
Okay, I'm definitely having a light bulb moment here. I'm starting to grasp not just what these models do, but why they do it so differently.
And that understanding is key. It empowers you to make informed decisions about which model to use, how to prompt them effectively, and how to interpret their responses.
You're right. This is way more helpful than just seeing a list of model names and descriptions. Now, I'm dying to dive deeper into these reasoning models and their superpowers. What are some specific situations where they truly excel and what makes them so fascinating?
Well, there are 7 key areas where reasoning models truly shine, and each one highlights a unique capability that sets them apart. Buckle up, because we're about to explore the fascinating world of reasoning model superpowers.
Okay, hit me with those superpowers. I'm ready to be amazed.
First up is navigating ambiguous tasks. We touched upon this earlier, but it's worth emphasizing. Reasoning models thrive in situations where information is incomplete, unclear, or even contradictory.
It's like they're the Sherlock Holmes of the AI world, always up for a good mystery. Can you give us a real-world example of how this plays out?
Absolutely. Think of a company like Hebia, which uses AI to help legal and financial professionals analyze complex documents. They found that reasoning models were able to understand user intent even when given limited or ambiguous instructions, making them ideal for navigating the complexities of legal language and financial regulations.
So they're not just processing words, they're understanding the underlying meaning and intent. That's really powerful. What other superpowers are on the list?
Next, we have finding a needle in a haystack. This refers to their ability to sift through mountains of data and pinpoint those critical insights that might otherwise be missed.
So they're like the ultimate research assistants, tirelessly combing through information to find the hidden gems.
Exactly. And this isn't just about brute force searching. Reasoning models employ sophisticated algorithms and techniques to identify patterns, anomalies, and relationships that might escape the human eye.
Can you give us an example of this in action?
Take Index, an AI platform that analyzes financial data. In one instance, their reasoning model was reviewing company documents and flagged a seemingly minor change of control clause in a loan agreement. This clause stipulated that if the company was sold, a $75 million loan would immediately become due.
Whoa! Talk about finding a needle in a haystack. That's a $75 million detail that could have easily been overlooked.
Exactly. And it highlights the potential of these models to uncover critical insights that can have a significant impact on business decisions and outcomes.
Okay, I'm starting to see why these reasoning models are getting so much attention. What's the next superpower on our list?
Number 3 is finding relationships and nuance across large data sets. Reasoning models excel at connecting the dots between seemingly unrelated pieces of information, revealing hidden patterns and subtle connections.
It's like they're piecing together a giant jigsaw puzzle, revealing a picture that wouldn't be visible if you just looked at the individual pieces.
Precisely. They can analyze multiple data sources, identify correlations, and even infer relationships that aren't explicitly stated.
Do you have an example of this in action?
Consider BlueJay, a company that uses AI for legal research. They found that reasoning models were significantly better than previous approaches at synthesizing information from multiple legal documents to arrive at a logical conclusion. This is especially valuable in complex areas like tax law, where you need to consider multiple factors and regulations.
That makes a lot of sense. So instead of just summarizing each document individually, they're understanding how they all relate to each other.
Exactly. And this ability to see the bigger picture is incredibly valuable in many fields, especially those that involve complex decision-making and analysis.
Okay, I'm hooked. What's the next superpower on our list?
Next up is multi-step agentic planning. This is where things get really interesting. Reasoning models can act as the brains behind an AI operation, delegating tasks to other models and coordinating the entire workflow.
Wait, so they're like the project managers of the AI world, making sure everything runs smoothly and efficiently.
That's a great analogy. They can break down a complex task into smaller steps, determine the best model for each step, and even adjust the plan on the fly based on the results of previous steps.
So it's not just about analyzing data, it's about understanding how to use that data to achieve a specific goal.
Exactly. And this capability opens up a whole new world of possibilities for automation and AI-powered decision-making.
Can you give us some examples of companies using this superpower?
Absolutely. Companies like Argon AI and Lindy.ai are using this capability to build AI systems that can handle complex workflows in fields like pharmaceuticals and customer service. For example, imagine an AI system that can not only diagnose a patient's condition, but also automatically schedule appointments, order tests, and even handle insurance claims.
Wow, that's incredible. It's like having a personal assistant who can not only understand your needs, but also take action to meet those needs.
Exactly. And as these models continue to evolve, we can expect to see even more innovative applications of this capability.
Okay, I'm already blown away by these first 4 superpowers. What's next on the list?
Number 5 is visual reasoning. This is where OpenAI's O1 model really stands out. It can understand and interpret complex visuals like charts, diagrams, even photos with poor image quality, something that was previously very difficult for AI models.
Wait, so it can actually see and understand images? That opens up a whole new world of possibilities.
It definitely does. For example, imagine an AI system that can analyze medical images to assist with diagnosis, or one that can review architectural drawings to ensure safety and compliance.
That's amazing. Are there any companies already using this capability?
Absolutely. SafetyKit, a company that specializes in risk and compliance, is using O1 to analyze images and ensure product safety. They found that O1 was significantly more accurate than previous models at identifying potential hazards and risks.
So it's not just about seeing the image, it's about understanding the context and implications of what it's seeing.
Exactly, and that's what makes O1 so groundbreaking. It's pushing the boundaries of what's possible with AI visual reasoning.
Okay, I'm officially adding visual reasoning to my AI vocabulary list. What's next on our list of superpowers?
Number 6 is code review. Reasoning models are exceptionally good at reviewing code, identifying potential errors, and suggesting improvements. They're like having a super meticulous programmer looking over your shoulder, but without the judgment.
So they're not just writing code, they're understanding it at a deeper level.
Exactly. And this is crucial because even small coding errors can have a big impact on the functionality and security of a software application.
Are there any companies using this capability in real-world scenarios?
Absolutely. CodeRabbit, an AI code review startup, is using reasoning models to automate code reviews and provide developers with detailed feedback on their code. This helps developers catch errors early on, improve the quality of their code, and ultimately deliver better software.
Okay, so reasoning models are like the ultimate code quality assurance team. What's the final superpower on our list?
Last but not least, we have evaluation and benchmarking for other model responses. Reasoning models can act as judges, assessing the quality and accuracy of responses generated by other AI models.
So they're like the quality control experts, making sure that all the AI models are performing at their best.
Exactly. And this is crucial because as AI systems become more complex and integrated into our lives, we need to be able to trust their responses and decisions.
Are there any examples of companies using this capability?
Absolutely. Braintrust, a company that specializes in AI evaluation, is using reasoning models to assess the quality of responses generated by other models, especially in sensitive fields like healthcare. This helps ensure that AI systems are providing accurate and reliable information to healthcare professionals.
Okay, that's incredibly important, especially in fields where even a small error could have significant consequences.
Exactly. And as AI continues to evolve, this capability will become even more crucial for ensuring that AI systems are operating safely, ethically, and effectively.
Wow, what an incredible rundown. You've officially made me a reasoning model enthusiast. But now I'm thinking about all the Python beginners out there who might be feeling a little overwhelmed by all this information. Is there a simple way to summarize the key differences between reasoning and GPT models?
You bet. Think of it this way. Reasoning models are your go-to for complex problem solving, deep analysis, and tasks that require a high level of accuracy and nuance. They're like the master strategists of the AI world.
And GPT models.
GPT models are your workhorses for speed and efficiency. They excel at well-defined tasks like summarizing text, translating languages, and generating creative content. Think of them as the quick and efficient task completers.
Okay, that's a really helpful way to remember the key differences. But now I'm wondering about the practical side of things. How do we actually talk to these powerful reasoning models? How do we give them instructions and get them to do what we want?
That's a great question, and it's one that often intimidates beginners. But the good news is that prompting reasoning models effectively isn't about mastering complex tricks or secret codes. It's more about clear communication and understanding how they think.
Okay, that's reassuring. So no need for an AI whisperer, just clear and concise instructions. But what are some specific tips to keep in mind when crafting these prompts? What makes a good prompt versus a bad one?
There are a few key takeaways from our research that can make a big difference in how well your reasoning models perform. And they're all centered around the idea of making things easy for the model to understand.
Okay, I'm all ears. Let's unlock those secrets to effective prompting.
First and foremost, simplicity is key. Reasoning models are surprisingly good at understanding straightforward, concise prompts. You don't need to overcomplicate things with fancy language or convoluted instructions. Think of it like giving directions to a friend. Short, direct, and to the point.
Got it. So no need to write a novel, just clear and concise instructions. Are there any other pitfalls to avoid when crafting prompts?
Yes. A common mistake is to tell the model to think step by step. While this might seem helpful, it can actually hinder the model's performance. Remember, these models are already designed to reason internally, so they don't need to be explicitly told to think step by step.
That's interesting. So it's more about setting the overall goal and letting the model figure out the best way to get there.
Exactly. It's like telling a chef how to chop vegetables when they're already a master of their craft. Trust the model to do what it does best.
Okay, that makes sense. So we've covered simplicity and avoiding the think step-by-step trap. What other tips can you share for crafting effective prompts?
Another important tip is to use delimiters to structure your input. This means using things like Markdown, XML tags, or section titles to clearly separate different parts of your prompt, such as instructions, data, and questions.
So it's like providing a roadmap for the model to follow, making it easier to understand the structure and purpose of the input.
Exactly. And when it comes to providing examples, the general advice is to start with zero-shot prompting and only use few-shot prompting if absolutely necessary.
Can you explain the difference between those two approaches?
Zero-shot prompting means giving the model a task without any examples. You're essentially relying on the model's existing knowledge and capabilities to understand and complete the task. Few-shot prompting involves providing a few examples to guide the model, which can be helpful for more complex or nuanced tasks.
So start simple with zero shot and only add examples if the model is struggling to understand what you want.
Exactly. Reasoning models are often surprisingly capable of understanding and completing tasks without any examples, so it's always worth trying zero-shot first. And if you do need to use examples, make sure they are highly relevant to the task and clearly illustrate the desired output.
Got it. So no need to overload the model with examples unless absolutely necessary. Are there any other tips you can share?
Yes. When defining the task, be as specific as possible. Clearly state any constraints, desired output format, or criteria for success. The more specific you are, the better the model will understand what you're looking for.
So instead of just saying, analyze this document, I should provide more context, like analyze this financial report and identify any potential risks to the company's profitability.
Exactly. The more specific you are about your end goal, the better the model will be able to meet your expectations.
Okay, I'm starting to feel much more confident about crafting prompts for these reasoning models. It's all about clear communication, well-structured input, and a good understanding of how these models think.
You've got it. And remember, practice makes perfect. The more you experiment with prompting these models, the better you'll become at communicating effectively and getting the results you desire.
So we've covered a lot of ground in this first part of our deep dive. We've explored the key differences between reasoning and GPT models, delved into the 7 superpowers of reasoning models, and even learned some essential tips for crafting effective prompts.
And don't forget about the new developer message parameter.
Oh, right. That's a recent change in the OpenAI API that's specifically designed for reasoning models.
Exactly. It's now the preferred way to provide instructions and context to those strategic O-series models.
Chain of command. That sounds intriguing. It makes it sound like we're giving orders to a highly trained AI squad.
Well, in a way we are. By using developer message, we're setting the overall goals and guidelines for the model's reasoning process. We're providing the strategic direction without dictating every step.
So it's less about micromanaging the model and more about empowering it to make its own decisions within the framework we've provided.
Exactly. We're giving the model the freedom to think critically and creatively while still ensuring that it's aligned with our overall objectives.
This is all starting to make a lot of sense. We're starting to see the power of these reasoning models and how to communicate with them effectively. But now I'm curious to learn more about the practical side of using them. Where can our listener go to find more detailed information about the OpenAI API and how to integrate these models into their Python projects?
That's a great question, and one we'll tackle in the next part of our deep dive. We'll explore the key sections of the OpenAI documentation, highlight helpful resources, and provide practical tips for navigating those docs with confidence. Stay tuned. So you're ready to dive into that OpenAI documentation and start building something amazing with these models. It can feel a bit like exploring a new city, but we're going to equip you with the map and compass you need to navigate it confidently.
I love that analogy. So where should our listener, who we know has about 3 months of Python experience, where should they begin their exploration? What are the must-see landmarks in this vast documentation landscape?
First, I would recommend revisiting the model section. Remember that feeling of being overwhelmed by the sheer variety of models? Well, now you can read those descriptions with a much deeper understanding. You'll see those model names not just as labels, but as indicators of specific strengths, limitations, and ideal use cases.
It's like we've unlocked a secret decoder ring for the OpenAI world. Instead of just seeing a list of models, we now understand what each one brings to the table. What other areas of the documentation would you highlight?
Next, I'd suggest exploring the guides section. This is where the real magic happens. You'll find practical guides, tutorials, and step-by-step instructions on a variety of topics like crafting effective prompts, fine-tuning models for specific tasks, and even integrating OpenAI models into your Python applications.
It's like going from reading a menu to actually learning how to cook. We're moving from theory to practice.
Precisely. And the guide section is full of those practical tips and tricks that can save you a lot of time and frustration. You'll find code examples, best practices, and even troubleshooting tips to help you along the way.
Okay, models and guides are definitely going on my list. What about for our listener who's ready to start writing some Python code? Where do they go to find those technical details?
That's where the API reference comes in. This section is essential for anyone who wants to start coding with OpenAI models. It's like the dictionary and grammar guide for speaking the language of the OpenAI API.
So it's where we learn the vocabulary and syntax for interacting with these models through code.
Exactly. You'll find detailed documentation on all the available API endpoints, parameters, and response formats. It's the technical manual for making those API calls and getting the results you need.
Now, when I first started looking at the API reference, I felt a little lost. It's a lot of information to take in. Are there any specific areas within the API reference that you'd recommend focusing on?
Of course. One section that's incredibly valuable for beginners is the Quick Start Guide. This is where you'll find a simple step-by-step guide for making your first API call. It's a great way to get your feet wet and see how easy it is to start using the OpenAI API in your Python code.
It's like the hello world of the OpenAI API, a simple starting point that gives you that initial sense of accomplishment.
Exactly. And once you've mastered the basics, you can delve deeper into specific API endpoints and explore the various parameters and options available.
Speaking of parameters, can you tell us a bit more about the developer message parameter that we mentioned earlier? I'm still a bit fuzzy on how it works and why it's so important for reasoning models.
Absolutely. Remember how we talked about the chain of command behavior of reasoning models? The developer message parameter is the key to unlocking that capability. It's how we as developers set the overall strategy and goals for the model's reasoning process.
Okay, so it's like we're giving the model a mission briefing, outlining the objectives and constraints, but without dictating every step.
Precisely. We're providing the high-level guidance, allowing the model to leverage its reasoning capabilities to figure out the best way to accomplish the mission.
And this is done through a specific parameter in the API call, right?
Exactly. Let's say you're using the OpenAI API to analyze a financial report. Your developer message might be something like, analyze this financial report and identify any potential risks to the company's profitability. This sets the overall goal for the model's analysis without specifying exactly how to do it.
So it's a way to steer the model's reasoning in a specific direction without micromanaging every step of the process.
Precisely. And this is what makes the developer message so powerful. It allows us to harness those sophisticated reasoning capabilities of these models while still maintaining control over the overall direction of the analysis.
That makes a lot of sense. Now, for our listener who's eager to start using the developer message in their Python code, where in the API reference can they find more detailed information?
The API reference provides comprehensive documentation on all the parameters and options available for each API endpoint, including the developer message. You'll find detailed explanations, code examples, and even usage guidelines to help you craft effective developer messages for your specific use cases.
So it's all there, ready and waiting to be explored. Now, as we're talking about the OpenAI documentation, I'm reminded of that initial feeling of overwhelm that many beginners experience. It's a lot of information to absorb. Do you have any advice for our listener on how to approach the documentation without feeling lost or intimidated?
Absolutely. First and foremost, remember that you don't need to understand everything at once. The OpenAI documentation is a vast resource, and it's designed to be explored gradually. Start with the basics, focus on the sections that are most relevant to your immediate needs, and don't be afraid to experiment.
So it's about breaking down the learning process into smaller, manageable steps.
Yeah.
Don't try to climb the entire mountain at once.
Exactly. And remember, the best way to learn is by doing. Don't just read the documentation passively. Try out the code examples, experiment with different parameters, and see what works best for you.
So embrace the learning process, make mistakes, and have fun along the way.
Exactly. The OpenAI documentation is designed to be interactive and engaging. So don't be afraid to roll up your sleeves, get your hands dirty, and start experimenting.
Now, I know from personal experience that sometimes, even with the best documentation, you can get stuck. What resources are available for our listener when they hit those inevitable roadblocks?
You're right. Getting stuck is part of the learning process. But the good news is that you're not alone. The OpenAI community is vast and incredibly supportive. There are forums, Discord servers, and countless online resources where you can find answers to your questions and connect with other developers.
So it's like having a network of AI mentors and guides who are always there to help you out.
Exactly. And these communities are full of experienced developers who are eager to share their knowledge and help beginners get started.
That's really encouraging. It takes a lot of the pressure off, knowing that you have a supportive community to turn to when you need help.
Absolutely. And don't forget, OpenAI is constantly evolving and releasing new models, features, and documentation updates. So it's important to stay curious, keep learning, and embrace the ever-changing landscape of artificial intelligence.
That's a great reminder. The world of AI is constantly moving, so it's important to be a lifelong learner and stay on top of the latest advancements.
Precisely. And with the knowledge and skills you gain from exploring the OpenAI documentation, you'll be well equipped to navigate this exciting world and unlock the incredible potential of artificial intelligence.
Okay, I think we've covered a lot of ground in this second part of our deep dive. We've explored the key sections of the OpenAI documentation, highlighted helpful resources like the Quick Start Guide and code examples, and provided practical tips for approaching the documentation with confidence.
And I think it's safe to say that our listener is now much better prepared to explore those docs and start building their own AI-powered application.
I agree. They have the knowledge, the tools, and the community support to embark on this exciting journey.
Exactly. And who knows what amazing things they'll create with the power of AI at their fingertips.
The possibilities are truly endless, and that's what makes this field so incredibly exciting. We've journeyed through the core concepts of reasoning versus GPT models and dove deep into those 7 superpowers of the reasoning models. And we've even equipped you with a roadmap to navigate the OpenAI documentation.
And remember, this deep dive was tailored for you, someone with about 3 months of Python experience. Excited about AI, but maybe initially a bit daunted by those docs?
Exactly. So as we wrap things up, I want to shift gears a bit from information to inspiration. Now that you've peeked behind the curtain of OpenAI, what sparks your curiosity?
Yeah. What problem are you itching to solve with these really powerful tools? What creative idea is bubbling up, just waiting for the right AI model to bring it to life?
That's the beauty of this field, right? There's no one right answer. The same way a painter chooses brushes and a sculptor selects chisels, you now have a sense of which AI models might be your perfect creative partners.
And remember that the OpenAI ecosystem is constantly evolving. New models, features, and documentation updates are released regularly, so stay curious, keep experimenting, and don't be afraid to revisit the documentation as you grow your skills.
Well said. This isn't a one-time learning sprint. It's a lifelong marathon of discovery and innovation.
And who knows, maybe the next groundbreaking AI application will be born from the seed of an idea sparked by this very deep dive.
I love that thought. So to our listener, we say, keep exploring, keep building, and keep pushing the boundaries of what's possible with AI.
Thanks for joining us on this deep dive into the world of OpenAI. Until next time, happy coding.
All right, Python explorers, let's talk OpenAI.
Yeah.
If you're anything like me, you dove headfirst into Python, you're 3 months in feeling good, and then bam, you hit the OpenAI docs.
Oh, yeah.
Suddenly it's like reading ancient Sanskrit, right?
It's a lot.
This deep dive is all about building a mental roadmap of those docs so you can approach them with confidence, not confusion.
We're going to decode the jargon and the concepts, especially focusing on the model selection document.
Right.
It's crucial stuff, especially for someone just starting out with OpenAI.
Yeah, this doc is like the instruction manual to a spaceship.
It is.
And the first big idea it throws at you is that when choosing your OpenAI model, accuracy is king.
Yeah.
But why is that such a huge deal, especially for a Python beginner?
Because a model that isn't accurate is essentially useless no matter how fast or cheap it is. Think about it. If you're building a chatbot and it only gets the user's intent right half the time, it's going to be a frustrating experience.
Yeah, you just want to chuck your computer out the window.
Exactly.
So before you even start thinking about which model to use, you've got to know what good enough looks like for your project.
Yes.
What's fascinating is the doc actually talks about calculating the financial impact of accuracy.
Oh, yeah.
Can you break that down for us?
Absolutely. They use a fake news classifier as an example.
Okay.
Imagine correctly classifying an article saves you $50.
Right.
But getting it wrong costs you $300 because you need human review.
Oh, wow.
The doc shows how to calculate the minimum accuracy you need to at least break even.
Okay, that makes the stakes crystal clear.
Yeah.
But then the doc throws another curveball, model distillation.
Right.
What in the world is that? I mean, is this some secret AI alchemy?
It's a cool technique, actually. Imagine training a super powerful model, but it's a resource hog to run.
Okay.
Model distillation is like taking all that learned knowledge and transferring it to a smaller, leaner model. It's like teaching a student the essence of what the master knows.
So you're essentially creating a mini-me version of the big expensive model, but hopefully without sacrificing too much accuracy.
Exactly. That smaller model becomes faster, cheaper to run, and potentially easier to integrate into your Python projects. The doc also talks about this amazing prompt baking technique.
Oh, yeah?
Collecting effective prompt and completion pairs as you go.
Oh, yeah. That stood out to me, too. I'm guessing this is super valuable for a Python beginner because it's like building your own cheat sheet of what works.
Precisely. It's like having a library of proven prompts that, will generate good results as you experiment with different prompts and get good completions. You can save those pairs and reuse them in future projects,
Right.
saving time and boosting your results.
That's a fantastic tip. Okay, so we've talked about aiming for accuracy, but then the document emphasizes that it's just the first step.
Yeah,
You then optimize for cost and latency.
right.
Why is it so important to do it in that order?
Because again, if your model isn't accurate, it doesn't matter how fast or cheap it is. It's like having a race car that can't stay on the track speed is useless without control.
Makes perfect sense. So once we've hit our accuracy goals, what are some of the strategies for keeping costs down and speeding things up?
The document lists a few, and we've already touched on one model distillation, but there's also reducing the number of requests you make to the API, minimizing the number of tokens you use, and even choosing a smaller model from the get-go if you know it'll be accurate enough.
Right. It seems like they're really emphasizing that you don't always need the biggest, most powerful model to get the job done.
Absolutely. It's about finding the right tool for the job.
Yeah.
Sometimes a smaller, more specialized model will be more than sufficient, and it might even surprise you with how well it performs.
Now, to illustrate all of this, they dive into a practical example with this fake news classifier,
Yeah.
setting specific targets for accuracy, cost, and latency. They actually run 3 different experiments to see how different approaches stack up.
And I think walking through these experiments will really help solidify the concepts for our listeners.
Right.
Seeing it in action is often the best way to learn.
Agreed. So let's dive into those experiments and see what they reveal.
Sounds good. Let's start with experiment number 1. All right, so their first experiment is what they call a zero-shot approach. They take the mighty GPT-4o model, give it a simple prompt, and feed it 1,000 news articles to classify as fake or real.
Zero shot sounds intense, like the model gets 1 shot and that's it, no practice rounds.
Exactly. It's like asking someone to identify a rare bird species based on a single description. It can work, but it's not the most reliable method.
And in this case, the results weren't stellar, right?
They hit an accuracy of 84.5%, which remember falls short of their 90% target.
So zero shot with GPT-4o is a no-go. What do they try next?
For experiment 2, they stuck with GPT-4o but added a few-shot learning twist. They gave the model 5 examples of correctly classified articles before letting it tackle the remaining 905.
So it's like giving the AI a little cheat sheet showing it what a fake article and a real article look like.
Precisely, and with just those few examples, the accuracy jumped up to 91.5%, hitting their target.
Nice. So problem solved, right? We found the perfect approach.
Well, not quite. Remember, we also need to consider cost and latency. While the few-shot approach nailed the accuracy, it was pretty expensive because those extra examples added more tokens to the prompt.
Right. More tokens mean more processing power, which equals more cost.
Yeah.
So on to experiment 3, the final showdown. What did they try this time?
This is where it gets really interesting. They decided to use a fine-tuned model, but this time with GPT-4 Mini, the smaller, more cost-effective sibling of GPT-4o.
Okay, so smaller model, but with fine-tuning. For those of us who are new to this, can you explain what fine-tuning actually means?
Think of it like this: you have the smaller model that's already pretty good, but it could be even better with some specialized training. Fine-tuning is like giving it a crash course specifically on classifying fake news.
So instead of general knowledge, it's getting laser-focused on the task at hand.
Exactly. To do this, they used 1,000 labeled examples, articles that were already correctly identified as fake or real. It's like giving the model a study guide with all the answers highlighted.
And what were the results of this fine-tuned GPT-4 Mini approach? Did it hit the accuracy target?
Drumroll please, is it also achieved 91.5% accuracy, matching the few-shot GPT-4o model.
Wow, so same accuracy, but with a smaller, potentially cheaper model. This is getting good.
It gets even better. Remember how the few-shot approach was too expensive? Well, the fine-tuned GPT-4o Mini came in at a fraction of the cost.
Hold on, let me check the document. Okay, wow. It says they achieved the same performance for less than 2% of the cost. That's incredible.
Pretty impressive, right? And they did all this using only 1,000 labeled examples.
This is giving me a whole new perspective on model selection. So what's the key takeaway here for our listeners who are just starting out with Python and OpenAI?
Don't jump straight into fine-tuning. Start with your accuracy goal and see if you can hit it with a powerful model like GPT-4o, even if it's a bit pricey at first. Use that process to gather labeled examples and then explore fine-tuning a smaller, more efficient model like GPT-4 Mini.
It's a 2-step process. Aim high to see what's possible, then refine and optimize to make it practical.
Exactly. By following this approach, you can build effective AI-powered applications that are also cost-effective and efficient.
This is fantastic.
Yeah.
It feels like we've unlocked a secret level in the OpenAI world.
I like that analogy, and the best part is now that you understand these core principles, you can apply them to any project you're working on, not just fake news classification.
So it's about having a framework for approaching any problem you might encounter in the OpenAI documentation, regardless of the specific task.
Precisely, this document gives you a roadmap, a set of guiding principles to help you navigate the complexities of model selection and optimization.
This is gold. I'm so glad we did this deep dive. I feel way more confident about tackling the OpenAI documentation now.
Me too, and I hope our listeners feel the same way. Remember, it's all about taking it one step at a time, understanding the concepts, and experimenting.
Speaking of experimenting, the document's conclusion makes an interesting point. You often can't jump right to fine-tuning because you might not have enough labeled examples.
That's crucial. It circles back to the idea of using a powerful model like GPT-4o initially. You can use it not only to test your accuracy target, but also to gather those valuable labeled examples you'll need for fine-tuning later on.
So like a win-win. You're testing your approach and building your data set at the same time?
Exactly. It's all about being strategic and using the tools at your disposal effectively.
All right, so we've covered a lot. Accuracy optimization, fine-tuning, the whole shebang. But before we wrap up, let's zoom out for a second and think about the bigger picture. All of this has been focused on this fake news classifier example.
Mm.
How can our listeners apply these model selection principles to other Python projects they might be working on?
That's a great question. And the answer is they apply universally, whether you're building a chatbot, a language translator, a text summarizer, or any other AI-powered application. The core principles remain the same.
So no matter what you're building, start with accuracy, then optimize for cost and latency based on the specific needs of your project.
You got it. It's a framework that can guide your decision-making process no matter what you're building.
This is so empowering. It's like they've given us the keys to the kingdom.
I love that analogy, and the beauty of it is once you have these keys, you can unlock endless possibilities.
Okay, I'm feeling inspired, but I have to admit there's still one part of this document that's bugging me. They keep mentioning these different GPT models, GPT-4o, GPT-4o mini. Can you break down the differences between them in a way that a Python beginner can understand?
Absolutely. Think of it like this GPT-4o is like the heavyweight champion, super powerful, capable of handling complex tasks and generating highly accurate results. But all that power comes at a cost. It can be expensive to run and might not be the fastest option.
Okay, so it's like a supercomputer of language models.
Exactly. Now, GPT-4 Mini, on the other hand, is more like a lightweight contender. It's still very capable, but it's smaller, faster, and more cost-effective.
So it's a trade-off. You get speed and affordability, but potentially at the expense of some accuracy or complexity.
You got it. And choosing the right model for your project depends on your specific needs and priorities.
This is making so much more sense now. It's like choosing the right tool for the job. You'd use a sledgehammer to hang a picture, would you?
Exactly. And that's why understanding these differences is so important. It allows you to make informed decisions about which model will best serve your needs.
This is brilliant. I feel like we've gone from feeling intimidated by the OpenAI documentation to actually understanding it and feeling excited to use it.
That's fantastic to hear, and that's exactly what we set out to do. We want to empower our listeners to approach these powerful tools with confidence, not confusion.
Mission accomplished. So before we wrap up this deep dive into the OpenAI docs, I'm going to leave our listeners with a final thought-provoking question. Imagine you're about to start a new Python project, maybe that chatbot we talked about or something completely different. How would you apply these model selection principles? Accuracy first, then optimize to make your project the best it can be.
It's a fantastic question to consider because it highlights that these aren't just abstract concepts, they're practical tools you can use to build incredible things with Python and AI.
Exactly. And I think that's what makes this deep dive so powerful. We haven't just skimmed the surface of the OpenAI documentation.
Yeah.
We've really tried to understand the why behind the what so you can apply this knowledge in your own unique way.
I couldn't have said it better myself. So to our listeners out there, don't be intimidated by the OpenAI documentation.
Yeah.
You now have the knowledge and the framework to approach it with confidence. Dive in, experiment, and see what amazing AI-powered applications you can build with Python.
Yes. Go forth and build amazing things, and join us next time for another deep dive into a new topic where we'll uncover more fascinating insights and help you keep leveling up your skills. Until then, happy coding. All right, Python fans out there, have you ever looked at the OpenAI documentation and thought, whoa, this is a lot? Well, we're here to help you navigate it, especially if you're just starting out with Python. Think of this deep dive as your roadmap to OpenAI guiding you through all the core concepts.
And we're going deep. We'll break down those technical terms, demystify the architecture, and even share some tips to make your code run a lot smoother.
Yeah, think of this as your cheat sheet for building efficient OpenAI applications. And when we say efficient, we mean things like making your code run faster, like shaving off milliseconds from your processing time.
Yeah, that's right. Every millisecond counts when you're dealing with real-world applications.
And speaking of real-world applications, we'll be
Oh.
talking about a really interesting example later in this deep dive. We'll be looking at a customer service bot built with OpenAI. You'll see how all of this optimization stuff we're talking about comes together in a real project. But first, let's get back to the basics. When you look at that OpenAI documentation, you'll see these things called tokens. What are those?
So tokens are like the building blocks of language. They can be words, parts of words, or even punctuation. And it's what the OpenAI models use to understand and generate text.
Okay, so the model takes our text, breaks it down into these little pieces, these tokens, and then uses those to create responses. So how does that affect speed and efficiency?
Well, processing tokens takes time. The more tokens you have, the longer it takes to process. It's like if you imagine a puzzle with 1,000 pieces, it's going to take you longer to put that together than a puzzle with only 100 pieces.
Okay, so we want to give the model the smallest puzzle possible by optimizing our code and using tokens efficiently.
Got it. Now, the OpenAI documentation talks about 7 key principles for optimizing what they call latency. These are like the golden rules for building applications that run quickly and smoothly. Let's start with the first principle. Process tokens faster. How do we do that? One of the biggest factors that affects how fast your code runs is the size of the model that you're using. Think about it like choosing the right engine for your car. A smaller, fuel-efficient engine is going to be great for just driving around town, but if you need to tow a trailer or haul a lot of stuff, you're going to want a bigger, more powerful engine.
So we don't always need to pick the biggest, most powerful model, right?
That's right. Sometimes a smaller model like GPT-3.5 can actually be better for certain tasks than the larger GPT-4.
So it's all about choosing the right tool for the job. What are some other ways we can speed up that token processing?
Well, there's a cool feature that OpenAI has called predicted outputs that can really help. It's especially useful for tasks like editing code. Basically, you give the model a head start.
A head start, I like the sound of that. How does that work?
Imagine you're editing some code, and you already have most of the code that you want. With predicted outputs, you can give the model that code, and it will only process the changes that you made instead of processing the whole thing from scratch.
So we're kind of saying to the model, hey, you already know this part. Just focus on the new stuff. That's really clever.
Yeah, it can make things a lot faster because it reduces the number of tokens that need to be processed.
I love it. Okay, moving on to principle number 2, generate fewer tokens. So I'm thinking this one is all about being concise and to the point, right?
Yeah, absolutely. The shorter your output, the faster your code will run. It's a simple idea, but it makes a big difference.
Okay, so how do we actually reduce those output tokens? Is it just about writing shorter responses?
It's a little more than that. There are a few strategies, and the best one really depends on what kind of output you need.
Okay, give us some examples.
Well, for natural language, like if you're generating text, you can ask the model to be more concise in your prompt. Instead of saying something like, write a detailed explanation of X, you could say, summarize X in 3 sentences.
So we're basically training the model to give us the short version. What about if we're working with code or data?
For code and data, we need to think about our syntax. Things like using shorter function names, maybe leaving out named arguments when you don't need them, and making your code as clean and organized as possible can all reduce the number of tokens.
So it's about being efficient and smart with our code. Before we move on, I want to ask you about something you mentioned earlier, max tokens and stop tokens. I've seen those in the documentation, but I'm not really sure what they do.
Oh, those parameters let you set limits on how much text the model will generate. They can be helpful if you want to prevent the model from going on, or if you want to make sure that the output fits a certain length.
So max tokens basically says, don't generate more than this many tokens, and stop tokens tells the model to stop when it sees a certain word or phrase.
Exactly. But it's important to use those carefully. If you set those limits too low, you might end up with incomplete or choppy responses.
Okay, so use them with caution. Got it. Now let's talk about principle number 3. Use fewer input tokens. I'm guessing this has to do with the prompts we give to the model.
You got it. The length of your input affects how fast things run, although not as much as the output length.
So we should try to keep our prompts short and sweet.
Yeah, but don't stress too much about every single word. Unless you're working with a huge amount of text, you can probably focus on the other principles first.
Good to know. And finally, principle number 4, make fewer requests. This sounds interesting. Tell me more.
This is all about reducing the back and forth between your code and the OpenAI API. Each request takes a little bit of time, so if you can bundle multiple tasks together into one prompt, you'll see a performance improvement.
So it's kind of like making a grocery list instead of going back to the store for each item individually.
That's a great analogy. Instead of sending multiple separate requests, you combine them into one bigger request and streamline the whole process.
I like it. We've covered a lot already. We talked about tokens, those first 4 principles of latency optimization, and that customer service bot example that we're going to look at later.
And this is just the beginning. We have 3 more principles to discuss, and we'll see how they all work together in that customer service bot example. Welcome back. Are you ready for more OpenAI secrets?
Oh, I'm ready. Tell me more about those other optimization principles. You made them sound pretty interesting.
All right, well, let's jump right into principle number 5, parallelize. So this is all about making things happen at the same time, kind of like a team working together, everyone doing their part to reach a goal.
Ooh, I like that. A team working together. So instead of doing things one at a time, we're finding ways to do multiple things at the same time.
Exactly. It's like having multiple cooks in the kitchen, right? One can be chopping veggies, one can be stirring the soup, and someone else can be setting the table. Everyone's working at the same time, and the meal gets done faster.
Okay, I can see that. So how do we do that with our Python code when we're using OpenAI?
Well, let's say you have a few tasks that don't really depend on each other. They can each be done independently. You can split those tasks up and run them at the same time using Python's asynchronous features. That way, you can really use the power of your computer's processor and make things run a lot faster.
So we're not waiting for one thing to finish before starting the next. We could have multiple things happening at the same time and get more done.
Yes, exactly. And this can be really helpful when you're doing things like grabbing data from different places or making calculations that don't depend on each other.
And what about tasks that do depend on each other? Are we stuck doing those one at a time?
Not always. There's a really neat trick called speculative execution that can help even with those.
Speculative execution. Okay, now you have to tell me more about that. That sounds really interesting.
All right. So let's say you have 2 tasks. And the outcome of that first task is usually pretty predictable. You can actually start both tasks at the same time. And if you were right about the first task, you've basically saved yourself all that time you would have spent waiting.
So we're taking a bit of a gamble, but if we're right, it pays off big time. Are there any examples of that in the OpenAI world? Like, when would you use speculative execution?
Oh yeah, definitely. Imagine you're building an app that does content moderation, right? So you need to check if the content is okay before you do anything else with it.
I'm following you.
You could start processing the content and checking it at the same time. If it turns out the content is fine, you've already got a head start on things. But if it's not okay, well, then you just scrap what you've done. But usually it's worth the risk.
Yeah, I like it. Thinking outside the box. That's how we get that extra speed boost.
All right, now let's move on to principle number 6. Make your users wait less. This one is all about the user experience. We want to make sure people don't get bored waiting for things to happen.
I think that's so important. Nobody likes staring at a loading screen forever.
You're absolutely right. There's a big difference between just waiting and actually seeing progress. So we want people to feel like things are happening even if there's a lot going on behind the scenes.
Yeah, so how do we do that? How do we create that sense of momentum?
Well, there's a technique called streaming. This basically lets you send data to the user as it's becoming available instead of waiting for everything to be done.
Okay, so it's like when you're watching a movie online and you can start watching before the whole thing is downloaded.
Yeah, exactly. That's a great way to think about it. With streaming, the user sees things happening right away, and it makes the experience more engaging.
It keeps things moving. Now, are there any other tricks for making those wait times seem shorter?
Chunking is another good one. So imagine you have some output that needs a bit of extra work before it's ready to show the user. Maybe it needs to be translated or formatted or something like that. Instead of doing all that at once, you break it down into smaller pieces and send each piece to the user as it's finished.
Okay, so it's like giving them appetizers while the main course is still cooking. Keeps everyone happy.
Precisely. And don't forget about the visual cues. Things like progress bars or those spinning loading icons can make a big difference. Even just breaking a big task down into smaller steps can help.
Yeah, it's about managing expectations, letting people know that things are happening. Okay, we're down to the last principle, Tell me about number 7.
All right, principle number 7. Don't default to an LLM. Now, this one might seem a bit strange at first.
Wait, what? Don't use an LLM. But we're talking about OpenAI, and OpenAI is all about LLMs, right?
Yes, that's true. But the point here is that LLMs are very powerful, but they're not always the best way to solve every problem. Sometimes a simpler approach can actually be faster and more efficient.
Okay, I'm listening. Give me an example.
All right, well, think about something like a chatbot that has a set of predefined responses. Instead of using an LLM to generate those responses every single time, you could just store them in a table and look them up directly.
Oh, I see. So sometimes it's better to go with the simple solution instead of relying on the LLM for everything.
Exactly. And there are other things you can do too, like pre-calculating some results or using visual elements to show information in a more efficient way.
It's about being smart and choosing the right tool for the job. Sometimes the simple tool is the best. So how do we know when to use a simpler approach instead of an LLM?
It really depends on the task. Ask yourself some questions. Is there a limited set of outputs? Can I calculate some of the results ahead of time? Would it be better to show this information visually instead of using text? If the answer to any of those is yes, then maybe you don't need an LLM.
Okay, work smarter, not harder. Sometimes the simplest solution is the best. Well, we've gone through all 7 principles now. My brain is full of ideas. But I still really want to see how this all works in a real project. Can we finally talk about that customer service bot now?
Of course. Let's take a look at how we could optimize a customer service bot using everything we've learned.
Okay, perfect. Let's do it.
All right, so imagine we're building a bot that helps customers troubleshoot issues with the product. The user sends a message explaining their problem, and the bot needs to figure out what's going on. Maybe ask for more info if it needs to, and then, think about the situation and give a helpful response.
It sounds like a lot of steps. I can see
Yeah.
how all of this optimization stuff could come in handy. So where do we even start?
Well, if we looked at how this bot is built right now, we might notice that it's making a bunch of separate calls to GPT-4. And that's not ideal because remember, each request adds a bit of a delay.
Uh-huh. This is where that make fewer requests principle comes in, right?
You got it. We can group some of those calls together into one bigger prompt. Like instead of asking GPT-4 to understand the user's question and then separately asking it to check for missing information, we can do both at the same time.
Okay, fewer requests. Got it. What about the model? Do we always have to use GPT-4?
Well, not always. Remember the process tokens faster principle. Sometimes a smaller, more focused model like GPT 3.5 can do the job just as well, and it'll be much faster, especially for those simpler tasks.
So it's all about choosing the right tool for the job. We could maybe use GPT 3.5 for things like understanding the user's message and checking for missing information.
Exactly. Now, let's think about parallelization. Are there any opportunities to run things at the same time with this bot?
Let's see. The bot has to understand the user's question and then figure out what to do about it. Could those things be done in parallel?
They definitely could. When the bot is trying to understand the question, there are lots of little things it's doing, like checking for keywords, analyzing the sentiment, things like that. And those can often be done at the same time.
So instead of waiting for each of those little steps to finish, we can do them all at once.
Right. And that can save a lot of time.
Okay, so we've combined requests, we're using a smaller model for some things, and we're running things in parallel. Is there anything else we can do to make this bot even faster?
Well, remember the principle about generating fewer tokens? We can apply that to the bot's output too. Like, let's say we're using JSON to store some of the information the bot needs.
Like the bot's memory or information about the product?
Yeah, exactly. We can shorten those field names in the JSON instead of using really long descriptive names like user message history. We could just call it history or something like that.
Yeah. And we could move any long explanations or comments out of the JSON and into separate documentation.
Yes, good point. Every little bit helps.
It's amazing how many things we can tweak to improve the speed.
And the best part is that all these principles can be used for all kinds of OpenAI projects, from chatbots to code generation to creative writing tools. It's all about making things run smoothly.
I'm feeling so inspired. I want to go and optimize all my code now. But before we wrap up, I want to make sure I've got this all straight. Can we quickly go over what we've learned? All right, so here we are, the final part of our deep dive into OpenAI optimization. We've learned so much, but I'm ready to bring it all together.
Me too. We've covered a lot of ground with those 7 principles. Now it's time to put them into practice.
You mentioned recapping the customer service bot. I think that's a great place to start.
Okay, sounds good. Let's go over the key changes we made to make that bot run faster.
First, we took all those calls to GPT-4 and combined some of them into a single prompt. That really cut down on the number of requests.
Yeah, that was a big improvement. Minimizing those back and forth trips to the API can make a huge difference.
And then we talked about maybe using a smaller model like GPT 3.5 for some of those tasks, recognizing that GPT-4 isn't always the best choice.
Right. It's about picking the right tool for the job. Sometimes a smaller, more specialized model can do the trick, especially for things like understanding the user's question or checking for missing info.
And then we talked about parallelization, running things like retrieval and reasoning at the same time instead of one after the other.
Yeah, parallel processing can really speed things up, especially when you have tasks that can be done independently.
It's like having a whole team of chefs in the kitchen. They can get a meal ready so much faster if they're all working on different things at the same time.
Exactly. And remember those JSON fields, the ones we used for the bot's memory and stuff? We shortened those names and moved those long explanations to the comments.
Oh, yeah, I remember that.
Yeah.
It didn't seem like a big change, but it really helps to reduce the number of tokens the model has to deal with.
And every token we save makes the bot run a little bit faster, so it all adds up.
I'm really starting to see how all these little things can make a big difference.
It's all about being mindful of the details and optimizing every step of the process.
This deep dive has been so helpful. I feel like I have a much better understanding of how to use the OpenAI documentation now and how to build applications that run really well.
And that's what we were hoping for, to give you the knowledge and tools you need to navigate the documentation and build amazing things.
So what are the main things our listeners should remember as they start working with OpenAI?
Well, those 7 principles of latency optimization are key. They're your guide to building high-performance applications. Keep them in mind as you're building.
Process tokens faster, generate fewer tokens, use fewer input tokens, make fewer requests, parallelize, make your users wait less, and don't default to an LLM. Got it. Those are going to be my mantras from now on.
That's great. And don't be afraid to experiment. Try different things, test different models, and see what works best for you. There's no one right way to do things.
I love that. Always be curious, always be learning. And it's so inspiring to know that even if you're just starting out with Python, you can still build really cool things with OpenAI.
Absolutely. Start small, learn the basics, and gradually build up your skills.
Well, this has been an incredible journey. I'm so excited to see what our listeners will create with everything they've learned from this deep dive.
I am too. OpenAI has so much potential, and I can't wait to see what developers come up with next.
That wraps up our deep dive into the OpenAI documentation. We talked about key concepts, optimization secrets, and even built a customer service bot together. I hope you're feeling inspired to unlock the power of OpenAI and build incredible applications with Python. Until next time, happy coding. All right, so, when you're just starting out with Python, one of the things that can seem really intimidating is the OpenAI documentation.
Yeah.
Especially when you've only got about 3 months, under your belt with Python. It can feel like a whole other language. But that's why we're here today, to kind of break down the OpenAI universe.
Right.
So that it makes sense before you even open up the documentation.
Yeah, getting a lay of the land is always helpful.
I like it.
Making sure that you are equipped with, a clear roadmap and have some of those key concepts and technical terms down pat.
And not feel lost in the jargon.
Exactly.
Yeah. So for this deep dive, we're going to focus on how to make those LLMs or large language models really work for you.
Okay, cool.
And where's the best place to kind of start that journey?
Well, I think you can't talk about working with LLMs without starting with prompt engineering.
Okay.
It really is the foundation for pretty much everything you do with these models.
I've heard that term thrown around a lot, prompt engineering. What does it actually mean in practice?
At its core, it's all about crafting clear and effective instructions for the model.
Okay.
You're essentially guiding the LLM to understand what you're asking and to produce the kind of output that you are hoping for.
So it's more than just typing in a random question. You need to be kind of deliberate with how you're phrasing things.
Absolutely. And one of the most valuable things I think about prompt engineering is it forces you to really think critically about what accurate means for your specific project. You start by giving the model a simple prompt, and then you evaluate if the response that it gives you aligns with what you were expecting.
And if it doesn't quite hit the mark, that's where the real learning happens.
Exactly. When the output isn't quite what you envision, analyzing why that happened is crucial. It's like detective work, figuring out what needs to change in your prompt to get the result that you want.
So it's kind of an iterative process, bit of trial and error, but with a clear goal in mind.
Precisely. And the OpenAI documentation actually has a whole section that outlines some great techniques for making this whole process more efficient.
I am all ears.
Yeah.
What are some of the strategies they recommend?
One of the most fundamental tips is to write clear and concise instructions.
Oh.
Imagine you're explaining something to a friend who has absolutely no knowledge about that thing.
Mm-hmm.
Simple, direct language is key.
Okay, that makes sense. Keep it straightforward.
Yeah.
What else?
Often you'll want the model to handle a task that's quite complex.
Yeah.
Right, so don't overwhelm it with one massive prompt.
Okay.
Break it down into smaller, manageable steps.
Okay.
It's like creating a to-do list for the LLM.
So baby steps are better for those complex asks.
Exactly. Another really important tip is to factor in thinking time,
Okay.
especially if you're giving it a complex prompt, right? It requires more processing time.
Yeah.
So don't expect instant results. Patience is a virtue when it comes to LLMs.
Got it.
Give them time to think it through.
Give those models time to work their magic.
Right. And when you are making changes to your prompts, approach it systematically.
Good.
Tweak one thing at a time, observe how the output changes, and then make further adjustments. It's like a science experiment
Yeah.
with controlled variables.
Yeah, speaking of experiments, the OpenAI documentation had that really interesting example of using GPT-4 to correct Icelandic sentences. I
Yeah,
don't know if you remember that one.
I do. It's a perfect example of how powerful prompt engineering can be.
Mm-hmm.
By crafting the right prompts, you can really leverage these models for incredibly specific and nuanced tasks.
It's fascinating how we can take, a model trained on a massive amount of data
Mm-hmm.
and then fine-tune it for such specialized applications.
Yeah, it really is.
It really is. However, even with the best prompt engineering, you are going to run into situations where it's just not enough
Right.
to achieve maybe the level of accuracy or complexity that you need for a project.
Absolutely.
So when we hit those limitations, where do we go from there? What are kind of the next steps?
So that's where evaluation becomes really critical.
Okay.
You need to rigorously test your prompts with a set of questions and compare the model's answers to what you know to be the correct ones.
Yeah.
It's like grading the model's homework.
That sounds like it could be a very time-consuming process, especially if you're dealing with a lot of data.
Absolutely. Which is why automating the evaluation process is so important.
Okay.
And there are some helpful techniques that you can use to streamline that.
I'm always up for saving time.
Right.
Tell me more about those automated techniques.
Yeah, so one common approach is to use metrics like Rouge or BERT score.
Okay.
These provide a quick snapshot of how much the model's output has changed
Okay.
after you've made adjustments.
So are these like perfect scoring systems that tell you exactly how well the model is doing?
Not exactly.
Okay.
Think of them more like compasses.
Okay.
They don't always perfectly align with human judgment,
Mm-hmm.
but they give you a general sense of direction, and they can indicate whether you are moving towards improvement.
So it's more about just getting a sense of the trend rather than a perfect score.
Exactly. Another powerful method, which might sound a little bit meta,
Okay.
is using GPT-4 itself as the evaluator.
What?
Yeah, you can actually provide GPT-4 with a predefined scorecard and criteria to assess the output of your model.
Wow. Using AI to evaluate AI.
Yes.
I hadn't even considered that.
Yeah, it's a cool technique, and the GVal paper outlines that really well.
Okay, cool. So what if we've exhausted all our prompt engineering efforts? We've evaluated the results and we're still falling short of our goals. What's kind of that next level?
That's when we start looking beyond just tweaking the instructions.
Okay.
We need to think about giving the model more to work with more information to really enhance its learning. That's where two key approaches come into play.
Okay.
Retrieval augmented generation, often shortened to RAG,
Okay.
and fine-tuning.
All right. I'm ready to dive deeper into these.
Okay.
What exactly is R
Okay.
and how does it work?
Imagine you're taking an exam, and you are allowed to bring a textbook. That textbook is going to be full of relevant information that will help you answer the questions.
Right.
RAG works in a similar way.
So instead of just relying on its internal knowledge,
Mm-hmm.
the model gets access to kind of external resources.
Exactly. With RAG, we provide the model with the relevant information directly within the prompt.
Oh, okay.
So it's like giving it a customized study guide.
Got it. But how do we ensure that RAG is actually effective?
Right.
Are there any potential pitfalls?
There are definitely things that we need to watch out for.
Okay.
There are two main areas where RAG can break down. First, you have what are called retrieval problems.
Okay.
This is like studying the wrong chapter for your exam.
Got it.
This happens when either the wrong context is retrieved or the model gets overloaded with too much irrelevant information,
Okay.
leading to confusion and incorrect outputs.
So it's like the model is experiencing information overload.
Exactly.
Okay.
Then you have what are called LLM problems. This is when the retrieval process functions flawlessly, so it gets the right information, but the LLM itself still misinterprets it or misuses it.
So even with the right page open, it's still kind of misunderstanding the material?
Unfortunately, yes.
Okay.
As powerful as LLMs are, they are not infallible.
Yeah.
They can make mistakes, particularly if they haven't been specifically trained for the task at hand.
Got it. So with R, we need to be mindful of both the retrieval process and the LLM's capacity to comprehend and utilize the information that's given.
Precisely. Now let's shift our focus to that other powerful technique I mentioned, which is fine-tuning.
Okay.
This is where we actually delve into training the model
Okay.
for specific tasks.
You mentioned earlier that fine-tuning is kind of like giving the model an entire curriculum.
Yes.
Can you elaborate on that a little bit?
Yeah, sure. Let's stick with that chatbot example that we've been talking about.
Cool.
Say we want to train our chatbot to handle customer complaints effectively.
Okay.
Very common use case, but it can be quite tricky.
Yeah, definitely.
Instead of just giving it generic instructions on like, hey, be polite and be helpful,
Right.
we can actually fine-tune it using a data set of real customer complaint conversations. So this data set would contain examples of identifying what the customer's issue is, empathizing with their frustration, offering solutions, and then ultimately resolving the complaint.
Right.
By training the model on the specialized data, we essentially teach the nuances of dealing with complaints in an effective way.
It's as if the chatbot is attending a customer service training,
Exactly.
like a crash course.
Fine-tuning on this specific data would improve both its accuracy, meaning it's more likely to understand the complaint and propose the right solution, but also its efficiency.
Okay.
It can handle those complaints more swiftly and seamlessly.
That makes a lot of sense, and I can see how that would be really valuable. But are there any potential pitfalls with fine-tuning? Anything we should watch out for?
One of the biggest traps is using low-quality training data. Remember that training data is really the foundation upon which the fine-tuned model is built.
Yeah.
So if that data is inaccurate, incomplete, or biased, the model will inherit those flaws.
So garbage in, garbage out.
Exactly.
Yeah.
Another common mistake is not providing enough training data.
Okay.
Fine-tuning really needs a substantial amount of data to be truly effective.
Yeah.
It's like studying for an exam. The more practice you have, the better prepared you'll be.
We need to make sure that the model has enough study material to master the task at hand.
Precisely. And remember, it's not just quantity, it's the quality of that data.
Right.
So we need to carefully curate the training data and ensure that it truly reflects the real-world scenarios that the model will encounter.
Yeah, it all comes back to that representative data.
Exactly.
Now we've discussed prompt engineering, RAG, and fine-tuning.
Yeah.
How do these all kind of fit together in the big picture? Are they separate strategies, or can they work in tandem?
They absolutely can be combined. Okay, in fact, often the most powerful and effective LLM solutions arise from blending these approaches.
So they kind of work together synergistically.
Exactly. Think of it this way.
Okay.
Prompt engineering gives the model its toolbox.
Okay.
RAG grants it access to this vast library of external knowledge. And fine-tuning provides specialized training.
Okay.
When you combine those elements, you really are equipping the model for success.
So it's not about choosing one approach over another. It's about finding the right blend for your specific needs.
Exactly. That's right. That's where the art and the science of LLM optimization really come together. It's about understanding the tools that you have, experimenting, evaluating, and iteratively refining your methods until you achieve those results that you were looking for.
It's like we're unveiling the secrets behind the magic of LLMs.
It is. There's definitely a sense of wonder. And the most exciting part is that we're really just scratching the surface of what's possible with these models as this technology continues to advance.
Yeah.
Who knows what incredible applications we will be able to create.
Yeah. The possibilities seem limitless. But let's bring things back down to earth for a moment. You mentioned earlier that achieving perfect accuracy with LLMs can be a challenge.
Right.
So how do we determine when a model is good enough to deploy, in a real-world scenario?
That is the million-dollar question.
Yeah.
And it's one that every LLM developer, I think, grapples with. There's no one right answer because it really does depend on a number of factors, including the specific use case, the potential consequences of errors,
Yeah.
and frankly, your tolerance for risk.
So it's a bit of a judgment call based on a careful assessment of the situation.
To a certain extent, yes.
Okay.
But there are some guidelines that we can follow to make more informed decisions.
Okay.
One approach is to consider the cost of errors.
Mm-hmm.
What's the worst case scenario if the model makes a mistake?
Right.
So let's say your model is powering a chatbot that's there to help customers troubleshoot some technical issues. An error might lead to some customer frustration, right?
Yeah.
But if it's controlling a self-driving car,
Right.
the consequences could be far more severe.
Yeah. The stakes are definitely higher in certain applications.
Absolutely. And that needs to factor into your evaluation.
Mm-hmm.
Another really critical consideration is the level of human oversight.
Okay.
Will the LLM be operating completely autonomously? Or will you have humans involved in monitoring its performance and intervening when necessary?
So even if the model isn't perfect, we can kind of mitigate risks by having humans in the loop.
Precisely, it's about striking that right balance
Yeah.
between automation and human intervention, and that balance will vary depending on the application.
That's making a lot of sense. So there's no like magic formula for deciding when an LLM is good enough.
Right.
It's about carefully weighing those risks, those costs, and the level of human oversight that you're willing to have.
Exactly, and it's an ongoing process.
Okay.
As you gather more data about the model's performance in real-world scenarios,
Yeah.
you can refine your assessment and make adjustments as needed.
This has been so insightful. I feel like I have a much clearer grasp on the intricacies of LLM optimization.
I'm so glad to hear that this field is constantly evolving,
Yeah.
so there's always more to learn.
Mm-hmm.
But hopefully this discussion has given you a good, solid foundation
Definitely.
to build on
Yeah.
as you delve deeper into this world
Yeah,
of LLMs.
definitely. But before we move on, I'm curious to hear your thoughts on one more thing. You mentioned that we're just scratching the surface of what's possible with LLMs.
Right.
What are some of the most exciting developments that you see on the horizon?
That's a tough question.
Yeah.
There is so much innovation happening right now.
Yeah.
It's hard to choose, but if I had to pick a few, I would say personalized learning,
Okay.
creative content generation,
Yeah.
and scientific discovery are all areas where I think LLMs have the potential to truly revolutionize the way we live and work and learn.
Those are some truly inspiring possibilities. It's exciting to think about how LLMs will continue to shape our world.
Absolutely. It really is an incredible time
Yeah.
to be working in this field.
Yeah.
Who knows, maybe one of our listeners will be the one who develops the next groundbreaking LLM application.
Yeah, that would be something.
Right.
Well, on that note, it's time to wrap up this part of our deep dive into the world of OpenAI and LLMs.
Okay.
We've covered a lot of ground today, from the fundamentals of prompt engineering to the nuances of RA and fine-tuning.
Yeah.
We've explored the challenges of evaluating LLM performance and the importance of considering both business and technical aspects when deciding if a model is ready for real-world deployment.
Absolutely.
And we even touched upon, the exciting potential
Right.
that lies ahead as this technology continues to advance.
Yeah, it's a lot to take in.
I don't know about you, but I'm feeling incredibly inspired.
Me too.
Yeah.
It's really an amazing time
Yeah.
to be working with these models.
Yeah.
And I hope our listeners are feeling just as excited about the potential as we are.
I'm sure they are. So to our listeners out there, thank you for joining us on this deep dive into the world of OpenAI and LLMs. We hope you found it informative, engaging, and maybe even a little bit mind-blowing.
Yeah, definitely a lot to think about.
Yeah,
And remember, the best way to learn is by doing.
absolutely.
So I encourage you to open up those OpenAI docs, start experimenting, and see what incredible things you can create.
We can't wait to see what you build.
Me too.
Until next time, keep exploring,
Keep learning.
keep learning, and keep pushing the boundaries of what's possible with AI.
Happy coding, everybody.
Hacky coding.
It's so inspiring to see what people are doing.
Yeah,
It really gives you a sense of like, okay, this stuff can actually be used
absolutely.
to solve real problems.
But let's circle back to Argy for a moment.
Okay.
You mentioned two main areas where it can kind of stumble.
Yes.
Retrieval problems and LLM problems.
Right.
Could you kind of walk us through those in a little bit more detail?
Sure. So let's imagine you're building a chatbot to help customers
Okay.
with questions about your company's products.
Okay.
So your chatbot's knowledge base would likely consist of like product documentation,
Right.
FAQs, support articles.
It's like giving the chatbot access to a library of product information.
Exactly.
Yeah.
But what happens when the retrieval process goes wrong,
Okay.
right? Let's say a customer asks, what's the battery life of the new X1000 smartphone?
Okay.
If the retrieval system doesn't pull up the right document,
Yeah.
maybe it grabs specs for a different phone or an outdated manual,
Hmm.
the chatbot's going to give an incorrect answer.
So it's like it's searching in the wrong section of the library.
That's a great analogy.
Yeah.
And that's just one type of retrieval problem.
Right.
Another issue is providing too much irrelevant information.
Okay.
So if the chatbot tries to cram every single detail about the X1000
Hmm.
into its response, it would be super overwhelming
Yeah.
and confusing for the customer.
It's information overload.
Exactly.
So it's not just about finding the right information. It's also about finding the right amount.
Absolutely. Now let's switch gears and talk about LLM problems.
Okay.
So this occurs when the retrieval process works perfectly.
Okay.
So the chatbot finds the right information,
Right.
but the LLM itself still misinterprets it or misuses it.
So even with the correct page open, it's still kind of misunderstanding the material.
Right.
Okay.
While LLMs are undeniably powerful,
Yeah.
they are not infallible.
Right.
They can make mistakes, particularly if they haven't been fine-tuned for that specific task.
That makes sense. So with Arago, we really need to be mindful of both the retrieval process and then the LLM's capacity to understand
Right.
and then use the information that it's given.
Exactly.
Okay. Let's shift our focus back to fine-tuning. You mentioned earlier that it's kind of like providing the model with an entire curriculum.
Yes.
Can you elaborate on that a little bit?
Yeah, sure.
Okay.
So let's go back to that customer service chatbot example.
Okay.
Say we want to train it to specifically handle complaints. Instead of just saying be polite and helpful,
Right.
we could actually fine-tune it on a data set of real customer complaint conversations.
Okay.
So this data set would contain examples of identifying the customer's issue, empathizing with their frustration, offering solutions, and then ultimately resolving the complaint.
Right.
So by training the model on this very specific data,
Yeah.
we essentially teach it the nuances
Okay.
of dealing with complaints effectively.
It's like the chatbot is attending a customer service training.
Exactly. And fine-tuning on this specific data would improve both its accuracy, meaning it's more likely to understand the complaint
Right.
and propose the right solution, but also its efficiency. It can handle those complaints faster and easier.
Right. And that I can see where that would be really valuable.
Yeah.
Are there any pitfalls with fine-tuning that we should watch out for?
One of the biggest things to be aware of is using low-quality training data.
Okay.
That training data really is the bedrock upon which the fine-tuned model is built.
Yeah.
So if that data is inaccurate, incomplete, or biased, the model will inherit those flaws.
Garbage in, garbage out.
Exactly.
Right.
Another common mistake is not providing enough training data.
Okay.
You really need a lot of data to fine-tune effectively.
Right, like studying for a test.
Exactly. The more practice you have, the better prepared you'll be.
The model needs enough study material.
Exactly. And remember, it's not just about quantity, it's also about the quality of that data.
Right.
You need to curate it carefully
Yeah.
and make sure that it reflects the real-world scenarios the model is going to encounter.
It all comes back to that representative data.
Exactly.
Now we've discussed prompt engineering,
Mm-hmm.
RG, and fine-tuning. How do these all fit together in the big picture?
Yeah, good question.
Are they separate strategies or can they work together?
They can absolutely work together.
Okay.
In fact, I would say that often the most powerful and effective LLM solutions come from blending these approaches.
So they work together synergistically.
Exactly.
Okay.
Think of it this way.
Okay.
Prompt engineering gives the model its toolbox.
Got it.
A RAG gives it access to a vast library of knowledge. And fine-tuning provides specialized training.
Okay.
So when you combine those elements, you're
Yeah.
really equipping the model for success.
So it's not about choosing one over the other.
Right.
It's about finding the right blend.
Exactly.
That's what you need.
That's where the art and the science
Mm.
of LLM optimization
Yeah.
really converge.
It's about understanding the tools, experimenting,
Yeah.
evaluating, and iteratively refining
Right.
until you get what you want.
Exactly. Until you get the results that you are looking for.
It's like we're unveiling the secrets behind the magic.
There's definitely a sense of wonder to it.
Yeah.
And the most exciting part is we are just scratching the surface
Yeah.
of what's possible
Yeah.
as this technology keeps advancing.
It feels like every day
Mm-hmm.
there's some new breakthrough or some new application.
Right.
It's incredible to see how accessible
Yeah.
this is all becoming.
And that's really, I think, what's so exciting.
Yeah.
That accessibility.
Yeah.
You know, one thing we haven't really touched on directly is how all of this connects back to actually navigating the OpenAI documentation itself.
That's a really great point because this whole deep dive is about giving our listener a head start
Right.
before they even open those docs.
Exactly. And I think the beauty of it is that once you grasp these core concepts, prompt engineering, RAG, fine-tuning, evaluation, the documentation becomes much less daunting.
Right.
Those terms don't seem like a foreign language anymore.
It's like having the decoder ring.
Yeah. Right. Suddenly you understand the structure,
Mm-hmm.
the terminology,
Yeah.
the logic of it all.
Right. You can navigate the different sections,
Mm-hmm.
find the specific information you need, and actually make sense of the code examples they give.
Right. And I can definitely see how understanding those concepts beforehand
Mm-hmm.
would make a huge difference. Instead of feeling overwhelmed,
Right.
you'd be approaching the documentation with a sense of confidence and purpose.
Exactly.
Yeah.
You'll be able to focus on the practical aspects, how to implement these techniques, experiment with different approaches,
Yeah.
and ultimately build something amazing.
And I think that's the most exciting part, is empowering our listener to not just understand these concepts, but to use them to create, to innovate.
Absolutely. And remember, there are a ton of resources out there beyond just the documentation.
Right.
OpenAI has a fantastic community forum, tutorials, blog posts, all designed to help you
Right.
succeed on this journey. It's like having a whole support network cheering you on
Exactly.
every step of the way.
Yeah.
So to our listener out there who's just starting their Python journey and feeling a little bit intimidated by this world of AI and LLMs.
Yeah. Take a deep breath.
Yeah.
Remember what we've talked about today
Mm-hmm.
and dive into that OpenAI documentation with confidence.
You got this.
You got this.
We can't wait to see what you create.
Me too.
Yeah, it really is. It feels like every day there's a new, breakthrough or application.
I know. It's really incredible.
It's incredible to see how accessible this technology is becoming.
It is, and I think that accessibility is really key. You know, one thing we haven't touched on directly is how all of this connects back to actually navigating the OpenAI documentation itself.
That's a great point because this whole deep dive is about, giving our listener kind of a head start
Right.
before they even open those docs.
Exactly. And I think the beauty of it is once you grasp these core concepts, prompt engineering, Raksha fine-tuning evaluation, the documentation becomes so much less daunting.
Yeah.
It's like all of a sudden.
Yeah. Those terms don't seem like a foreign language anymore.
Exactly.
It's like having a decoder ring.
Yeah.
Suddenly you understand the structure,
The terminology.
the terminology,
Yeah.
the logic
The logic of it all.
of it all.
Right? You'll know how to navigate the different sections, find the specific information that you need, and actually make sense of those code examples that they provide.
I can definitely see how understanding those concepts beforehand
Right.
would make a huge difference instead of feeling overwhelmed.
Right.
You're approaching the documentation with a sense of, confidence and purpose.
Exactly. You can really focus on like the practical aspects.
Right.
How do I implement these techniques?
Yeah.
How do I experiment with different approaches?
Right.
And ultimately, how do I build something cool with this?
And I think that's like the most exciting part, right?
Mm-hmm.
Is empowering our listener to not just understand these concepts, but to use them to create, to innovate.
Absolutely. And remember, there's a wealth of resources available beyond just the documentation.
Right.
OpenAI has an incredible community forum, tutorials, blog posts,
Yeah.
all designed to support you on your journey.
It's like having a support network cheering you on every step of the way.
Exactly.
So to our listener out there who's maybe just starting their Python journey and feeling a little bit intimidated by this whole world of AI and LLMs.
Take a deep breath. Remember what we've talked about today and dive into that OpenAI documentation.
Yeah, you got this.
You got this.
We can't wait to see what you create.
Me neither.
And that wraps up another deep dive.
Yes.
Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible with AI.
Happy coding, everyone.
Happy coding. All right, Python Explorer, welcome to a deep dive just for you. You're about 3 months into your Python journey and ready to tackle the OpenAI docs.
Ugh.
It's a smart move, but I know those docs can feel like a jungle sometimes.
It's true, they can be pretty dense. But think of this deep dive as your machete, cutting through all the overgrowth and uncovering the gems hidden inside will help you build a mental map before you even step foot into the territory.
Oh, I love that analogy. So instead of getting lost in all the technical details right away, we're going to lay down some foundational understanding first.
Exactly. We're going to break down the key concepts and the terms in a way that makes sense for someone at your level. So when you do open up those docs, you'll feel confident instead of that, feeling.
Perfect. Feeling confident is half the battle, right? So let's jump right in and start with something that I've heard a lot about large language models. What are those in simple terms?
Imagine you have this super talented friend who can write anything you ask for. Poems, code scripts, even musical pieces. All you have to do is give them some clear instructions. That's basically what these large language models do, these LLMs.
So it's like having an AI writing buddy on call 24/7. That sounds amazing, but how does it actually work?
No, well, these models are built on something called generative pre-trained transformers, which sounds super complicated, but just think of them as really powerful algorithms that have been trained on massive amounts of text data.
Okay, so they basically read like everything ever written. That's a lot of reading. I guess that's why they're called large language models.
Right, and that extensive training allows them to understand the nuances of language and generate creative text formats based on, as you said, clear instructions. We call these instructions prompts. It's like programming the model to give you exactly what you need.
Prompts. Got it. So crafting a good prompt is key to getting a good output. Makes
Yes.
sense. But here's something that's always bugged me. Have you ever tried the same prompt like twice and got completely different results?
Yeah? Yes. The mystery of non-deterministic outputs.
Yeah.
It can be a little frustrating, but it boils down to the fact that even with the same prompt, the model's internal workings can lead to slight variations each time. Think of it like asking a chef to make the same dish twice. It'll taste similar, but there might be subtle differences.
Okay, that helps. But let's say I need to get the same result every single time, like in a scientific experiment. Is there a way to control that randomness?
Absolutely. That's where the seed parameter comes in. You can think of it as like planting a specific seed to grow a specific plant. If you use the same seed value, the output will be the same each time.
So it's like a secret code for consistency. I like it. But have you ever encountered those moments where even with the same seed, the output still varies?
That can happen, yeah. Sometimes OpenAI makes these behind-the-scenes changes to their models. It's like they're constantly fine-tuning the recipe. They do provide a system fingerprint field to help you track those changes, so, when something might be different on their end.
Good to know. Now let's move on to another concept. I've been hearing whispers about tokens. What's the deal with these tokens everyone's talking about?
Tokens are like the building blocks of language for these models. Imagine you're building a structure with Lego bricks. Each brick is a token, and the model uses these tokens to create its output.
So if words are like bricks, then a sentence is like a Lego creation.
Exactly. But here's the interesting part. A token isn't always a whole word. It could be part of a word or even punctuation. It's the smallest unit of text the model works with.
Wait, so a single word could be multiple tokens?
Precisely. For example, a long word might be split into 2 tokens. And even a simple phrase like ChatGPT is great is actually 6 tokens, not 3.
Oh, that's kind of mind-blowing. So why should I care about these tokens? They seem pretty small and insignificant.
They might be small, but they have a big impact on how you use the API. First off, you pay per token when using OpenAI services. Longer prompts and outputs equal more tokens, which equals higher costs.
So tokens equal money. That definitely makes me pay attention. What else should I know?
While processing those tokens takes time. More tokens mean longer processing time, which can slow down your application. And finally, there's a token limit for each model. For example, GPT-3.5 Turbo has a limit of 4097 tokens. You can't just throw a novel at it and expect a response.
So tokens are like a precious resource that I need to manage carefully.
Exactly. Understanding tokens is crucial to using the OpenAI API effectively.
All right, Token Master. We're back and ready to dive deeper into the strategies for managing those precious tokens, especially when we're dealing with chat models. It feels like we're about to unlock the secret level of this game.
I like that analogy. And you're right, managing tokens effectively is crucial for building smooth and cost-effective applications, especially those involving chat interactions.
So where do we begin? What's the first rule of Token Management Club?
The first rule is to be mindful of how much information you're feeding the model at once. Remember, each message, your role, and the content all consume tokens. Instead of throwing a whole paragraph at it, try breaking it down into smaller, more digestible chunks.
So it's like having a conversation with a real person. You wouldn't just dump all your thoughts on them at once. You'd exchange information bit by bit, right?
Exactly. That back and forth allows for a more natural flow and helps prevent the model from getting overwhelmed.
Okay, that makes sense. So instead of giving the model like a huge backstory all at once, I could feed it sentence by sentence or maybe even phrase by phrase.
That's a great approach. It also gives you more control over the conversation and lets you guide the model in the direction you want.
Now, what happens when the conversation inevitably gets longer and we start approaching that dreaded token limit? We can't just like abandon the chat, can we?
Definitely not. This is where the second rule of Token Management Club comes in, managing the conversation history. If you're nearing the token limit, you'll need to strategically truncate or summarize earlier messages. It's like taking notes and condensing them as you go.
So it's like we're creating a greatest hits version of the conversation, keeping only the most important parts.
Exactly. But here's the challenge. You need to do it in a way that preserves the essence of the conversation so the model can still follow the flow and remember the key points.
That sounds tricky.
Yeah.
Any tips on how to summarize effectively without losing crucial information?
Well, one approach is to focus on the key actions and decisions made in the conversation. Think of it like a movie recap. You wouldn't include every single scene, just the plot-driving moments.
Okay, so we're looking for the turning points in the conversation. What else should we consider when summarizing?
It's also important to pay attention to any specific information the model might need to refer back to later. For example, if the user mentioned a specific date or preference earlier, make sure to keep that in the summary, even if it seems minor.
So it's like anticipating what the model might need to remember to keep the conversation coherent.
Precisely. It's all about finding that balance between brevity and clarity.
All right, I'm getting the hang of this. Summarizing sounds like a skill that takes practice, but it's definitely essential for keeping those conversations flowing. Is there anything else we can do to manage tokens, especially as the conversation grows?
There is. Another strategy is to consider the model's memory. Some chat models have a limited short-term memory, meaning they can only remember a certain number of previous exchanges.
So it's like having a goldfish as a conversation partner. They can only remember the last few seconds.
That's a fun way to put it. But in all seriousness, understanding the model's memory limitations can help you structure the conversation effectively. If you know it can only remember the last 5 exchanges, you can tailor your prompts and responses accordingly.
That makes sense. So if I need to refer to something that happened earlier in the conversation, I might need to reintroduce it briefly to refresh the model's memory.
Exactly. Think of it like giving the model little reminders along the way.
Okay, so we've talked about breaking down information, summarizing and managing the model's memory. Are there any other token taming techniques we should have in our arsenal?
There are a few more advanced techniques, but for someone at your level, these core strategies will give you a solid foundation for managing tokens effectively.
That's great. I'm feeling much more confident about tackling chat models and those token limits now.
And remember, practice makes perfect. The more you experiment with these strategies, the more intuitive they'll become.
Well, speaking of practice, I'm eager to put some of these token management skills to the test. What other OpenAI secrets are you ready to reveal? Okay, we've covered a lot of ground in this deep dive. We talked about large language models, decoded the mysteries of tokens, and even learned some ninja-level token management techniques. What else can we explore in these OpenAI docs?
Well, now that you have a good understanding of the fundamentals, let's delve into some of the more advanced features that give you even finer control over the model's behavior. Think of it as taking your AI skills to the next level.
I'm ready for a level up. What kind of tools are we talking about?
One interesting concept is the idea of frequency and presence penalties. These are parameters you can adjust to influence how repetitive the model's output is.
Wait, so we can actually control how much the model repeats itself? Why would we want to do that?
It's all about fine-tuning the style and coherence of the output. Sometimes, especially in creative writing tasks, the model might get stuck in a loop generating the same phrases or ideas over and over again.
Ah, I see. So it's like telling the model, hey, be more original. I've already heard that one.
Exactly. The frequency penalty specifically discourages the model from using tokens that have appeared frequently in the text. The higher the penalty, the less likely it is to repeat those tokens.
Okay, so it's like a seen it, heard it filter for the model. What about the presence penalty? How's that different?
The presence penalty is even stricter. It discourages the model from using any token that has already appeared, regardless of how often it's been used.
So it's like saying once is enough. Let's try something new.
Exactly. By adjusting these penalties, you can control the level of repetition and novelty in the model's output. For factual summaries, some repetition might be fine, but for creative writing, you'll likely want to crank up those penalties to encourage more originality.
That's pretty cool. It's like we're learning to speak the model's language, giving it subtle cues to guide its behavior.
Are there any other advanced techniques that can help us understand how the model is thinking?
There is. One particularly insightful feature is the concept of token log probabilities. It might sound technical, but it's actually a fascinating way to see the likelihood of the model choosing different tokens at each step of the generation process.
So instead of just seeing the final output, we get to see the model's thought process as it's like creating the text.
Precisely. It's like peeking behind the curtain and seeing all the different paths the model could have taken before settling on the final output.
That's incredible. What can we learn from seeing those different paths?
It can be invaluable for debugging understanding why the model made certain choices, and even exploring alternative outputs. For example, if you see that the model almost chose a different word that would have completely changed the meaning of the sentence, it can give you valuable insights into its decision-making process. Wow, that's really powerful. It feels like we're going from just using the model to really understanding how it works on a deeper level.
Exactly. And that deeper understanding is what will ultimately allow you to use these tools more effectively and creatively.
Well, I have to say, I started this deep dive feeling a bit intimidated by the OpenAI docs, but now I feel like I have a much clearer roadmap and the confidence to start exploring on my own.
That's fantastic to hear. Remember, the OpenAI documentation is a treasure trove of information and tools. Don't be afraid to experiment, try different parameters, and see what happens.
You've given us the keys to unlock a whole new world of possibilities.
Enjoy the journey, and remember, the most important thing is to keep learning, keep experimenting, and most importantly, keep having fun with it.
Thanks for joining us on this deep dive. Until next time, happy coding.